Hello everyone, my name is Felipe. I'm a full-stack software engineer and machine learning engineer working in the tech industry. I work as a tech consultant for many industries, from lawyers, VFX, advertising, spatial agencies, and a bunch of other things, security, defense. I'm really excited to collaborate one more time with Rebelway, giving you this amazing new course. So first of all, this is an applied machine learning course, so we're gonna go hands-on and to actually using a bunch of already pre-established models, but checking the backend architecture. The other side will be to develop the architectures ourselves, training models in all sorts of scenarios for a production. This can be any kind of production, but we are focusing on the tech side of things. It can be for software engineering, game development, visual effects, whatever it is, animation in general. We're going to establish some utilities and some home pipeline, how we can make some things useful. So a bunch of different things and production techniques will come along the way. We're going to talk a lot about geometry, 3D point data manipulation, 3D geometry polygon manipulation. We're going to take a deep dive in computer vision as well. It's going to be extremely essential, all the tools we're going to see, like motion capturing, 3D data reconstruction for facial expressions, action recognition, pose estimation. We're going to animate a 2D image based on the pose estimation for a source video. A lot of utilities for countless industries. One utility, besides all the automation and pipeline and asset QC and all of that, how you can deploy models, how you can make it more production ready and actually work in a team sense. Lots of tools, like for example, removing the background from an image. In an image that you don't have to create a mask, you don't have to create a chroma key, the models actually detect how the main character, the main subject in the image will be, and extract with really fine detail in a really complex scenes. You can apply that logic to your own renders and create masks that you don't have. So we're gonna programmatically with an AI system create some masks. A lot of backend architectures will be explained, so you have further knowledge on everything that's happening here. We're gonna do depth estimation based on images, videos, so you can extract 3D data. We're gonna dive deep into point clouds as well, because they are essential for many things in today's standards. Taking a step from point clouds, we're going to check how generative 3D geometry is being used, is being created nowadays. Now, obviously, again, all the time you see there's a new model for this, there's a new model for that, 3D geometry wise. But if you see that, it's not production ready. It's something nice to have at this moment, it's not there yet. But I'll show you some techniques so you can actually use it, for example, for a quick prototype, and you will see some demos in Unity. Or also you can have like a strong base mesh so you can work on top and quickly prototype some assets. So this is not like that example from Apple Intelligence where they're trying to sell you there's a new thing like Apple Intelligence is the best thing in the world, where in reality it's just some generative AI generated emojis and that's it. So we're taking the opposite route in here. I'm showing you actual practical use AI. We're gonna show lots of production techniques like deepfakes, AI based texturing. And again, maybe this texture is not the final one ready for production, but the main idea is to actually identify features in a 3D geometry. For example, the AI will know this is where the eye is supposed to be in your model, this is where the hair is supposed to be in your model. Is actually detecting the features of your character. This is a dog, this is a chair, whatever. Lots of production techniques where you can expand that better, so maybe you can also populate assets with that knowledge. I'm gonna show you a little demo on how I did a bunch of things, and everything you see here in the screen is AI generated except for the character. Every single asset is AI generated, even the grass. I needed to experiment how the grass is gonna move, first of all, like how the grass is gonna look, the shader for the grass. And the second thing, I wanted to explore new calling techniques for this particular game I'm testing. Calling techniques in terms of hierarchical calling, occlusion calling, camera calling, a bunch of things. So I need an environment with full grass. So everything you see in the shot is AI generated for that reason, to quickly prototype what I actually need to prototype. So in this case, from the start idea to actually having all of this in-game, it took me like an hour, maybe an hour and a half. By using the pipeline I'm gonna show you through around this course so you can quickly prototype things. Lots of different things in Houdini. This is a reinforcement learning environment with all the policies and rules and everything. And we're gonna train point data in Houdini so the points become agents and then they can obey some rules. I'm setting the rules so the points can avoid an obstacle, but this logic you can apply to anything. If you have a particle system, If you train the reinforcement learning well enough, you don't have to set colliders or a bunch of different things or maskings. The points will know how to avoid objects if you set in the rules to avoid. You can apply this to a crowd system, and then you can train it all the way so they can jump obstacles. The NPCs will have actual AI behaviors, actual human behaviors driven by AI, dialogues, all of these. So reinforcement learning will be a huge part in this. So we're gonna jump into Gaussian splatting, new techniques, because that's the new evolution of point clouds, which is actually dealing with volumes. So AI-based volumes is extremely exciting, being used in so many industries nowadays. I'll show you a bunch of tools, a bunch of utilities, how you can use, and the logic behind it as well. We're gonna go in and out of computer vision along the way because it's extremely essential. We're also gonna do some really useful utilities, like for example, extending animation. Say you have 500 characters with different animations, and for some reason you need to extend all of those. So we will do a sequence prediction to predict with a basic animation what are the next 10 frames for this animation, but the logic will follow to anything you wanna do. Lots of utilities like that, useful utilities, so you can extend models, extend animations, extend logic with LLMs, and a bunch of things like that. Going back again, we're gonna check deepfakes, all the technology behind deepfakes. We're gonna go hands-on for all of these I'm mentioning and actually start using it, and I'll show you like every single step along the way. One of the main parts of this course will be reinforcement learning as well. It's one of my favorite fields in the world of AI. We're gonna train agents. You're gonna start with something simple like using the gym from OpenAI, then we're gonna escalate that to an AI system that can play Mario Bros. So what's the usage of an AI playing Mario Bros? If you think on the big picture, if you start training an agent that can perform those actions, you can take it all the way into real life robotics, self-driving cars, self-landing rocket ships. If all of that stuff is being driven by reinforcement learning, so I'm showing you the basics on how that works. If you can make an agent play a video game, it can learn anything the agent wants. Also, we're gonna check deeply into LLMs, not just like chatting with an AI bot, how to really make it an assistant for your production. You can be a very specific Blender assistant, a very specific Houdini assistant, and if you mix it with reinforcement learning, it can actually perform actions like publishing shots, creating assets, and a bunch of different things. I'm gonna show you how to feed your own data for your own documentation, maybe for in-house documentation in your LLMs. So you will have an AI smart assistant in your company. You don't have to rely on waiting for a long time for tickets if you have an issue with something. If you feed it well enough with well enough data, with proper data, it will be really smart, and it can actually solve tickets for you. You can ask it about questions about the software in your company, your own in-house documentation. Since we are working in production, I'll show you everything about a production, APIs, how to track your experiments, how you can tackle a problem or a subject or something you need to do that AI is going to benefit you all along the way. And in the same way, we're going to check a bunch of really advanced topics. At the same time, we're also going to check the cheaper versions, which is traditional heuristic machine learning algorithms, which you will see along this course. It can save your life in a production. Sometimes you don't have to go like the super heavy route. So we're going to explore a lot in this course. But again, as I said, this is going to be practical AI, something that you can actually use in a production, something that's going to save you in terms of automation, in terms of streamlining a pipeline based on AI tools, smart asset QCs, your own AI assistant, point cloud generation, 3D generation, texture generation, reinforcement learning, AI playing games, AI performing actions, a bunch of things. We're gonna do lots of tools with computer vision again, depth estimation, color estimation, object tracking, pose estimation, extracting that data so you can actually use it, not just something that you can look at. I'm extremely excited for this. It's something quite unique, and all I'm describing here is just some parts of everything we're gonna see along the way. But it's gonna be extremely cool, and I can't wait to get started for this. Hello everyone, welcome to this new really exciting machine learning course. We're gonna explore lots of topics, we're gonna have so much fun. It's gonna be challenging for a lot of parts. Usually in the world of AI, there's gonna be a bunch of new updates, a bunch of new ways people are researching, being developed in hardware, software, algorithms, all of that. So nothing is fixed in terms of this is the only way you can do the thing. It's always this experimental stage. But it's really exciting. And there is also this iterative approach of dealing with multiple models, checking all the performance, doing it everything in the production concept. So we're going to explore all of that. It's going to be really fun. Now, this first video is just to cover some tools. We have a couple of videos like this as well, but this is the very first initial one. So in this video, I'm going to show you some concepts you should be familiar with. We're going to have a Python refresher, and we're going to check the concepts as we go as well. It's going to help you a lot if you're already familiar with a bunch of these concepts, but if you're not, it's not a big deal because we are going to touch bases on most of these and explore them a lot. Basically, we're going to divide this in the way we do it in an actual production. We're going to identify a problem or something we need to automate or fix or experiment. Everything in AI, it's all about experiments as well. So we need to keep track on those. And the first way we're going to deal with this is with a heuristic approach. So without even thinking on training models and all of that, what's the right, sometimes hard-coded approach of dealing with a piece of software or some kind of AI development? For example, let's say we're dealing with a maze solver algorithm, or we need some sort of enemies in our game development that's going to follow the player and stuff like that. We can use traditional algorithms for that. We don't need to train models, and potentially that's enough for your production. That would be the heuristic approach. Doing something quote-unquote primitive, but most of the times this is actually the correct response and the correct result you will use in a production. So usually in a machine learning production, we start with a heuristic. We do a bunch of tests, and based on that, that will be our base case. We're going to start diving more into traditional machine learning algorithms and see if it's actually outperforming our previous first model, which was with the heuristic approach. And that's how we're going to take our mindset and want to escalate that. Starting from traditional machine learning algorithms, mostly CPU based, we're going to go into the next iterative approach, which will be using parallel processing with GPUs. And that will mean using frameworks such as JAX, PyTorch, or TensorFlow. So those are kind of like the steps we take in a production. Sometimes I'm just going to go for one approach because it will take too long to do that every single time. But just be aware, if you haven't worked in a tech company before, this is the way we usually do this. It doesn't matter the industry, lawyer firm, medical fields, VFX, game development, tech, it's always the same approach. You go into this ladder of explorations, heuristics, traditional algorithms, and then really high-end GPU-based machine learning with deep neural networks and all of that in steps, and you measure everything along the way. So in case you're not that familiar with, for example, traditional machine learning algorithms, if you go in scikit-learn, which is one of the libraries, one of the frameworks you're going to use, you can explore a lot about this. So for example, what is the problem you're trying to solve? Is it a classification problem? Is it a regression problem? And so on. So maybe we need to cluster something. So you can go here and start checking these algorithms. So we're going to apply those directly in Houdini. Obviously, I'm going to explain, but it will benefit you to go and, for example, read all about k-means. And it will show you some formulas. It will give you an explanation about the k-means algorithm. And we're going to explore lots of these algorithms, create some tools, some HDAs in Houdini, and jump between DCCs. So in terms of what DCCs you need for this, is honestly up to you. That's the beauty about AI. It applies to everything. So if I'm showing you how to extract data and do some clustering algorithms, you can literally apply that to any industry, clustering bacteria behavior for medical fields, clustering assets for your game or your VFX shot, and so on, is how you want to apply that. There are no rules for this, which is really, really cool. So based on that, what I would suggest you to have, and we're going to definitely explore, will be obviously Houdini as our main DCC. We're going to check Blender. We're going to check Unreal Engine and Unity. So if you have those, it's going to be fine. You don't have to follow along. Again, it's the logic itself what you care about at the end. And where you apply that is up to you. But we're definitely going to explore those. As game engines, obviously Unreal Engine and Unity. And as DCCs will be mainly Houdini and Blender. But the same logic can apply to Maya, 3ds Max, whatever you want. Now, saying that, you see me right now using a Mac. I'm primarily a Linux user and a Mac user, but you will see me a lot using Windows as well. You don't have to do the same. For me, it's just honestly how I feel. Like I'm gonna develop on Windows one day, on Mac another day. If we're doing a bunch of Unreal Engine stuff that we will require, for example, the marketplace, the better experience for that is Windows. But for training models, you have to be in some sort of Linux environment, either in WSL or if you have a Linux machine, even better. So it's gonna depend on you. And we're gonna use scikit-learn, TensorFlow, PyTorch, and what's really important by the time of training complex models, you need CUDA processing or parallel GPU processing. If you don't have access to a CUDA machine, you can use Colab, which if you don't have experience with Colab, is a free machine allocated by Google, and they are giving you a GPU for free. You will see me using the Mac for a bunch of things, but from time to time I'm gonna SSH into my Linux machine, for example, to train a model and use that model in my Mac, in my Houdini, and so on. And this is my daily driver. Whatever is up to you, whatever is your daily driver. If you're doing everything in one machine, that's fine as well. Just keep track on your experiments, be organized. And from here, we will go into the very first start of this course. Hello, everyone. Welcome to the course. It's going to be something really, really exciting. We're going to explore a lot in many different fields, in many different disciplines, applications. This is all about applied machine learning. As we do experiments, check on what benefit we're going to have in our company, in our global development, why it's beneficial to have something automated, and not just the traditional way of automating things, but actually applying machine learning so the system will perform over time. We're going to see how to keep models fresh and everything. Obviously, you should have some familiarity with machine learning algorithms. It's not a big deal if you're not an expert or anything like that. You should be very familiar with Python, and you should already seen all the requirements for this course. I've seen some people in the past that they don't even know how to use a terminal or how to navigate in between Python environments and things like that. So we're not going to spend too much time on that. It's not a requirement that you took the previous machine learning course. You can start this from scratch by all means. So we're going to start diving in with some of the tools you're going to be used along this course. Some can be optional, some it's a must-have, and we're going to explore a lot. In this first videos, it's not going to be like exactly the things you're going to be using. Potentially we're going to change a lot along the way. I did already lots of experiments, so it's going to be really fun for this. You're going to improve a lot of things in your production if you work on a company or if you're a freelancer and whatnot. Automation is key. We have the keys to the future in AI, so it's our job to develop further. Anyways, let's start by explaining what I'm going to use throughout this course. I'm going to be using Windows. By all means, I have to say this right now, I'm not a Windows user at all. I haven't used Windows in many years. Primarily everything you will see in AI, in actual production, is going to be, everything's going to be Linux. Regardless the industry, the company, whatever, everything, all the training, all the architectures are being developed in Linux, running Linux. For many different reasons, not just efficiency, but the architecture itself will be built in there. Now, this doesn't mean you have to be a Linux user or you have to be using Linux right now. And you will see the pros and cons as we do everything. But I can tell you right now, in a company, in a real life company scenario, most of the pipeline and pretty much everything is going to be run in a cloud. So it doesn't matter what you use. You can even use an iPad if you want. You're going to be connecting to an external service. And we're going to do that a lot as well. So you can be using a MacBook Pro. It doesn't matter. We're going to connect to the cloud. But obviously, at the beginning, since we're going to explore a lot, we're going to be using your local machine, like my local machine, for example. So you can have already lots of experiments, because sometimes working everything in the cloud can be expensive and non-reliable, especially if you need to do lots of small experiments. So it's a good practice to do that locally. Sometimes it's a preference. You want to do everything locally with your computer power or just using the cloud. But keep in mind, everything in a company, in a production will be cloud-based. So we're going to explore both sides. As a main start, why am I using Windows? Because we're going to play a lot in Unreal Engine. We're going to play around a lot with DCCs, Houdini, obviously, and many different things. I already did a bunch of experiments. I'm primarily a Mac user because I use my Mac to connect to external services, but hands-on development is a great tool to have Windows and Linux at the same time. Luckily, we have WSL. this is a must-have. All the models, all the training, we're gonna be doing it in Linux and obviously in WSL if you're using Windows. So you need to have this set up already. Now, you can just look for Windows WSL like I have here, and you can install WSL. You should be already familiar with this. It's very standard to work like that. If you don't have it, by any case, you just install WSL. And the terminal will be our main stage. This is where everything's gonna happen, so you need to be familiar with the terminal. Now, Windows terminal sometimes gonna be useful. I can guarantee you, pretty much no one will be using a PowerShell Windows terminal in a production. Even if it's a game dev company, you have to be running some sort of server, some sort of service to connect, and that's going to be Linux based as well. But sometimes using automation scripts, batch scripts for PowerShell is useful as well. Now, I know not all of you will be using Windows, so we try to keep this in Linux as much as possible, or in a bash shell. So go ahead, install WSL. Again, we're gonna explore a lot. So if you open your Windows terminal, I'm just gonna open an instance here. This is gonna be PowerShell, right? You should be familiar with all the commands and everything. We're not gonna be doing much in here. Primarily our local machine pipeline, if I explain that a little bit, we'll be doing everything, all the training of the models, the data processing, everything in Linux, and all the application itself, for example, when we're using Unreal Engine or Houdini, all of that will be in the Windows side. So we're gonna do that communication, and it's a really powerful way of working, and it's a really standard way of working as well. So I already have some Linux distributions in here. I want to be using Ubuntu, so just install Ubuntu. It doesn't matter the version. I think I have 22 in here, but this is already my Ubuntu. As you can see, I already have Anaconda installed, and I have my Python environment. Lots of them for different experiments. We're gonna be creating, deleting, doing a bunch of play around with different environments. In terms of machine learning, we're gonna be using traditional machine learning algorithms, and then we're gonna use deep learning as well. For most of the traditional stuff, we're gonna be using scikit-learn, but from time to time, we're gonna define our own model architectures as well. So obviously, all of that will be done in Python. And besides that, the main frameworks we're gonna be using are gonna be TensorFlow, and it's gonna be PyTorch. So let's start by just checking TensorFlow. If you go into the TensorFlow website, you will have instructions how to install this. It's extremely simple. It used to be very complicated before. Now it's just a pip install. So in here, where you see the guide, we're gonna be using pip. So if you click here, and this is one of the first stages that you need to be familiar why Windows will be useless at some point. You can't even install TensorFlow in Windows anymore. So if you go Windows native, it's gonna tell you it's not possible. You need to do that in WSL. So it's gonna jump immediately into WSL. Obviously we're using WSL2. And the command you need to follow is this one. It's just a pip install TensorFlow with CUDA. Another reason why everything is on Linux. Everything in AI for most modern frameworks is going to be CUDA based, right? So TensorFlow, Python, JAX, you name it, everything is CUDA based. So we're going to explore this a lot of GPU accelerations, which is really, really exciting. But for now, just install it like this. It's going to be some issues at the beginning, especially using this workflow of Windows and WSL. So what you need to do is, first of all, TensorFlow by itself, depending on the version and when you're installing this, you will see the requirements in here. It's going to work with these versions of Python. I will suggest to use the latest one as possible. And it's going to need the NVIDIA configuration, especially this part here. So you need to install this version of the toolkit, which is 12.3 at the time of this recording. So check this version. If you go into developers for NVIDIA, I think you need to create an account. You can investigate this yourself. I'm not gonna do click by click. But in here, you will find that version. As you can see here, it's pointing us to 12.3. So if you find that one, for example, for me, it's this one here, and you will see the instructions how to install this in Linux. So for example, I'm in Ubuntu, I want this version of my Ubuntu, and I can choose dev local, and you see the instructions here to install that. You need to have that in order to have GPU acceleration. So before installing TensorFlow, before doing the pip install, make sure you have this CUDA toolkit installed, and then you can just run pip install TensorFlow between brackets and CUDA. So this command you see here. Once you have that, you can verify that you are using GPU by running this command. So if I go into my environment, obviously I'm in base, I'm gonna jump into my TensorFlow environment, which you can create by yourself. You know, if you're not familiar, you should be, but if you're not, it's not a big problem. So you just do conda create. This is to create an environment, -n for name, and then you name it here, some name. And you can specify the Python version in here, like 3.12, as we can see in the guide. So I already did this. I don't think I have 3.12 in my TensorFlow, but we can activate the environment. So for me, it's this one here. Mine is 3.10. I think I did this a while back. So if it gives me any issues, you can always update your Python versions within your conda environment. So I do have this, and I can paste that command to make sure I'm using CUDA acceleration. I should be seeing my GPU in here. So this is processing, and there we go. If you have multiple GPUs, it will be a list of GPUs in here. For me, I'm just using one, and I can see it. So everything I do in TensorFlow will be GPU accelerated. Same for PyTorch, which is even easier to install. It's going to install all the dependencies for you. You just go here, check the version. We are in Linux, we're going to do a pip install, and you can see with which CUDA you want to work with. In this case, if you select, for example, 12.4, you can just run this command. Obviously, it will be your own isolated Python environment. So we can jump out, conda deactivate. I'm in base, and on the info, on the -envs to check all my environments. I do have a torch environment in here. If I do pip list, I can see the version of torch I have. So mine is 2.1. Which one is the latest? 2.4. Maybe we can create a new environment so we can have everything up to date. It doesn't really matter. But if something gives us an issue, we can change the version, or we can create new conda environments. That's a powerful thing about working like that. So make sure you have TensorFlow and PyTorch. We will create another environments for scikit-learn. And as we go, I'm going to show you exactly which libraries we're going to be installing. But this is the very first steps. Just make sure you have WSL. Make sure you have all your conda environment set up. You can always just look for Anaconda. Check the instructions to install it if you don't have it already. It's extremely easy. And then from here, we can check really quickly what kind of other tools we're going to be using, like your editor. For me, my main editor for all the generic Python stuff is going to be NeoVim. And I use Tmux for my terminal multiplexer. So NeoVim is my main editor. So again, I do everything from the terminal, but I also use an IDE from time to time. I'm not that much of an IDE guy, but the tools I'm going to be using here will be VS Code, whatever extensions you want. Also, we're going to be using Cursor, which is a version of VS Code with Claude integrated, so you can chat with your code base. It's going to be our main AI assistant. That is Cursor IDE. This one here, extremely useful. We're going to be using this a lot along VS Code. If we run into some C++ applications in Unreal Engine or some of those experiments, we're going to be using Visual Studio. if you're not on Windows, you can install whatever IDE you want for C++, for Python. It's not mandatory. This is just some conveniences I use from time to time. That's why I'm explaining this. We're gonna be using Docker, so just go ahead and install Docker. So make sure you have some sort of container system. And from now, that's gonna be all for this. These are just some of the tools we're gonna be using. Really handy to have. Production tools. In terms of cloud tools, we're gonna be checking Google Cloud Services. And we're gonna be checking Amazon as well. And we're gonna do some experiments in Google Colab too. So make sure you're familiar with this. This is very standard again, but we're gonna be using this a lot. For our home pipeline, we're gonna be structuring that as we go. So how to communicate with Houdini, with different DCCs, how we're gonna have a centralized place for our experiment, data, and everything. So speaking of data, the main place we're gonna be checking, we're gonna be extracting data from some places, but from time to time, we're gonna jump in between Hugging Face and Kaggle. So make sure you have accounts for this. This is Hugging Face. We're gonna explore this a lot as we go as well. And Kaggle is very standard too. So we can access a bunch of data sets we wanna play around with. So these are the initial tools, and we're gonna keep exploring a lot as we go. Let's keep going. Now, obviously the main stage for our code and version control for everything will be GitHub. And we will keep checking different tools and websites as we go along. But the main repository for this course will be on GitHub, and your code, your experiments, all the version control will be in your GitHub as well. So let me explain that a little bit. If you're doing your experiments, your assignments, whatever you're doing for this course, ideally you can DM me on Discord and you will point me to your GitHub repo. It's really not ideal, it's not beneficial, and it's non-productive to just copy paste the code either in the main chat or in a DM. Just point me to your GitHub repo, and then that's the beautiful thing about version control. You keep versioning up your code, you can go back and check what you're changing and all that good stuff. So in your GitHub, let's actually create the new repository for this course. So let's call this one Rebelway Applied ML. This will be the main repo for this course. I'm creating it from scratch, so let's just do some random description here. I'm gonna set it to public, add a README, always advisable to do that. Let's add git ignore, it's gonna be Python, and this will be MIT, meaning you can do whatever you want with this code. Anyone can change it, anyone can do whatever you want. And there we go. The way we're gonna work with Git will be with Git work tree. So I'll explain that in the next videos. But basically, we're probably not gonna be pushing anything to main. We're gonna have a bunch of branches in here. And the branches, usually I split this based on concepts, not by weeks. For example, we're dealing with deep neural networks for CNNs or something like that. That will be in its own branch. The reason for this is if I split the branches in week 1, 2, and so on, later you won't remember like which topic is in which branch, like is CNN in week 3 or something like that. That's why it's better to structure this by topic, by different fields and explorations as we do this. So our branches will go here. Once we clone this repo, we will work with Git work trees, and we will keep our version control in there as well. But there you go. I just created the repo. You obviously need to clone this repo to follow along. By the time we end up this recording, everything will be populated. All the source code for everything will be here, and you can just grab it. You've created your own repo. You can fork this or create your own repo from scratch. Just make sure you have all the access, all the tokens for this. Now, right now, in case you haven't worked in a software company or in this kind of development stages, usually in a company, when you have your repo for your product, it will go in different stages, and I'll explain this in detail in the next videos as well. But it's not going to be the regular just copy this, clone, and you're good to go. In a company scenario, you will be dealing with SSH keys. Now, you can read the documentation from GitHub in order to deal with and download your SSH keys. When you're joining a company, you have a guide for this, so don't worry about that. Obviously, we're not going to be using this because we're not a company. We need to keep it more streamlined. But just bear in mind, in a company scenario, you will be dealing with SSH keys for security. For us, it's going to be HTTPS because we're just going to be cloning this and working in branches. But again, Git, our main stage, this is the official repo for this course, and everything will be uploading in here. So just make sure we are in the correct description. You will have access to this. And the first weeks, this will be pasted in the chat, so don't worry about this. But from here, we're gonna be uploading everything. Okay, so here we have our main repo. And we're gonna start working with Git work trees. If you haven't dealt with work trees before, the main reason we're gonna do that is because we're gonna be dealing with multiple branches. So one particular way of working in a company, if you have your main application, we usually divide that in multiple tasks for different team members or different departments, right? So if, let's say, your app is doing a chatbot, so lots of data, lots of integration to the application itself, there is a lot of development cycles in the structure of a piece of software, and it's no different than any other production. And what we need to do is, we're gonna go deep into all the concepts about design patterns, solid principles, separation of concerns, domain models, all of that good stuff, as we go and trying to productionize this more and more. But we're gonna have different branches for different parts of the application. Maybe you're doing debugging something. Maybe you're fixing a bug. Maybe you have branches for that. Maybe you have branches for experiments. Or if you're adding features to the application, you will have a branch just for features. And they will be very descriptive because, again, you're working as a team. This is for cross-functional stakeholders, for maybe clients and whatnot, for early stages of development. And we also want to talk about Agile here and there, the way we work in a software company. But we do have our main application, our main repository. This is main. In your company, no one will start working directly in main. It doesn't work like that. Main will be to present to these potential clients or the client itself. But ideally, you start working in branches and doing different smaller sections as you start dealing with your main case scenario. And that's the main logic about using work trees. So to give you one example, let's say you're working in a feature and you're assigned that feature. So you start working on that, and this happens all the time. Maybe priorities will change and then you need to work on something else. So you have to stash your code or save your changes or do something else. Or maybe you push in that branch, but obviously it's not ready because you just stopped working on that because you need to change for something else. And then you stop working in that branch, you check out that branch, and then you jump into a different branch because now you need to work on something else which has higher priority. So you start working on that maybe for a long time, and at some point you need to go back to your previous branch, but you don't remember which stage it is. Obviously it's going to be all broken and all of that. With work trees, you can work in multiple branches at the same time, which is really beneficial, and you don't have to worry about stashing or anything like that. So let's start checking that. I'm gonna copy this so I can clone it, and I'm here in some folder. You can choose whatever folder you want. In my case, I usually have this development folder on every machine, and this is where I do all my development. So in order to start working with this, we're gonna clone that, but we need to specify the bear flag, and we paste the address in here. By specifying bear, you're gonna work with Git trees. So if I clone my repo and then you go inside the folder, you can give it a name after that, so you can actually name it differently. For me, it doesn't matter. I'm just gonna go inside. If you haven't dealt with work trees again before, if you list this, you will see some strange things. All of this is a configuration so you can work in this branch scenario of a tree. In here, it's gonna work in folders, and every folder we create is gonna be a branch automatically. The way we can create that is, let's say we're gonna start, we need a branch just for our scikit-learn experiment or scikit-learn development in general. We can say git work tree add and the name of the branch. So for me, it's gonna be scikit-learn. And there we go. Now, if you check this, now we have a new folder called scikit-learn. So if I cd in there, and we can do git status, for example, you can see immediately, automatically, we are in the scikit-learn branch. Let's go back outside. We can create another branch. So git work tree, add, and maybe this one will be an experiment for our data input and output. So we can add experiment, maybe data IO for data input output. And now we have a new folder called experiment, and inside we have data IO, right? So let's cd in scikit-learn, and we can push this branch. So we're gonna do git push origin and then the name of the branch. You put here your username, and in here you need to paste your token. Your token will be your password. If you don't know how to generate a token, you go into your GitHub settings, you go all the way down to developer settings, and in here you can create your tokens. I usually use the classic one. You just create a new one. You generate a new token. Just be sure to toggle all the options you want in order for you to have the correct permissions to add, remove, update, and so on. At the end, you will have a token, so you can save that in some place. That's your password. I'm gonna paste my token, and there we go. Now I have a new branch. So in order to work with the structure we want, and having the branch experiment slash and then the experiment we're doing, we are here at root. We already saw that by going into the folder we want, we are in the branch and we can push that branch. In order for us to deal with the experiments, for example, we're gonna do the same, but we need to check out that branch. So git checkout -b for branch, and then the name of the branch. And for us is experiment data IO. I already created this, so if we remove -b, we're just gonna switch to that branch and we can push it. Just gonna paste my token again, and there we go. So now let's go to our repo. I'm gonna refresh this and double check the branches. So as you can see, now I have my scikit-learn branch where I can do all my work, and I do have experiment data IO. And that's the way we're gonna deal with branches. Probably we're not gonna push anything on main, but we will have our branch system. So in case you need to go to some specific topic, or you can do this yourself, you can just switch in between branches and start working like that. So before we jump in, let's just do some little experiment. This is me not hating Windows. We're not here for that. It's just not the OS I use on a daily basis, and this is nothing, again, to drive that point home. It's not me hating on Windows, but I'll show you one experiment why it's not ideal to use Windows as your base OS for machine learning development, or any kind of development in general. So I'm here in PowerShell. This is native Windows stuff. I just have a folder here. Actually, let's create a new one. I'm inside this folder, and one of the main downsides of using Windows will be the paths, right? So this is the path I'm currently on. Windows will work with backward slashes. Every single thing you do as a software engineer, machine learning, or dealing with any kind of computer logic, we don't use those. We use forward slashes. Right there, you need to change your development and use row strings in Python, or use escape keys and a bunch of different things that's just gonna make a headache for everyone down the chain. So the way Windows works with the path system is absolutely terrible. But beyond that, I'm here on this machine, right? I'm in my local machine. So you can't even use the touch command in Windows, right? Yeah, it doesn't work. So when I create a new file, let's call this one perf for performance. And in here, let's just do something very simple. I'm gonna import time, and then let's define some test function, right? All we're gonna do here is a loop. So for I in range, let's do 1 million iterations. So the loop is gonna run 1 million times, and for every iteration, we're just gonna print I to the power of 2, right? That's our function. Now our current time will be equals to time that monotonic. Very standard way of measuring time. So this is gonna record the current time as we launch, as we execute this program. We're gonna go in a refresher of computer architecture, what a program is doing behind the scenes, how your computer works in later videos, just in case you need a refresher for that. For now, we're just showing some things, why we need to use WSL or why we need to change some different things here and there. And again, I'm not saying Windows is completely useless. I'm not saying Windows is bad for these kind of things. It's just not designed for the kind of development we need to do. In the opposite way, there are going to be a lot of things that are excellent on Windows and maybe really, really bad on Linux or Mac OS. So it's always this kind of trade-off. But anyway, we're going to call in the function in here. And at the end, we're going to print the new current time, which will be also time that monotonic, and we're going to subtract that from the previous current time, right? This is going to measure how long this function is going to take to run. So we're going to save that, and we're going to execute this program. Now, let's run it. 3, 2, 1, go. So this is going for 1 million iterations on my local native Windows machine. So all of this is happening on Windows. You can see how long this is taking. Now, the way Python is designed will be a single core, a single thread dealing with this. But as you can see, it's taking a long time. I'm just waiting here. And there we go. It took 27.5 pretty much seconds to do this. So almost 30 seconds to execute that loop 1 million times. Now, the exact same machine, I'm just gonna switch this to Ubuntu WSL, and we can actually just copy paste the code. This is all my code. So I'm gonna copy that, go into Ubuntu, go into some folder as well. Let's do another folder. Now we can do the touch command because this is Linux. Let's call this one perf.py, same name. And we're just gonna paste literally the same code on the same machine, just switching this to Linux. And let's run this. There we go. This took 8.3 seconds to run that function. So this is the comparison we're talking about, and this is a really simple function. 1 million iterations is nothing in AI. So we went from 27.6 seconds on native Windows to 8 seconds on Linux in the exact same machine. I'm just switching to my WSL Linux. That's one of the main reasons we're gonna do that. Our experiments are gonna grow big in a production. The more you want to experiment, the more data you want and you need. Now this is running on CPU, single threaded, but still is a huge difference. If I run this on my MacBook, that one has an M3 Max chip, it's less than 1 second, this function. That's how way more efficient ARM processors are. But we're going to be, remember, running lots of things in parallel processing in a GPU. So we need to structure our things better. And the same logic will apply here. We need to make it more performant. That's why we are using Linux. And as you saw before, for example, with TensorFlow, you can't even do most things in native Windows. And that's why lots of different things, not just in the world of AI, are switching to stay and being built on Linux from scratch because of these kind of reasons. So just wanted to quickly point that. Now we can really start going deeper into all of these topics. All right, let's keep going. Now I'm gonna add this playlist in some document and upload it to the repo. I'm gonna create a new branch just for this OS stuff. You should be familiar with this. It's very, very important. You need to know how to use a computer. And I'm not talking about turning on the computer, replacing a graphics card and whatnot. Like actually know how to use a computer. So I'll definitely advise you. This is a long course, but it's extremely useful. Never mind about Windows, Linux, or Mac OS or whatever. This is the basics, the logic for an OS. You need to know how the computer works in terms of the hardware. What is a kernel? What is a kernel doing? How you're communicating in between pieces of your hardware? What are the instructions being sent by the CPU? What are the commands you need to use in the terminal? What's a shell? Kernels are really, really useful too, because we're not just gonna play around with libraries and just add some functions and just execute and expect some magic to happen. You need to be familiar why in some parts it's beneficial to use, for example, GPU acceleration for matrix multiplications. How do you deal with sparse matrices and stuff like that? A bunch of different things are going to be extremely useful for you, because the more you know, the better job you can do, the better things you can get done. You can debug faster, you can debug more accurately. Overall, it's an excellent skill to have, so I'll definitely recommend it to you. Check this course. Again, the link for this will be just in a text file in the repo. But I would advise you to check everything, especially for us. You really need to be familiar with what's a thread, the state of the actual processes in a machine, what's a race condition. And we're gonna do a refresher about computer architecture, especially with containers, in later videos. But for right now, knowing a bunch of these is extremely useful. Not just about your own development or faster iteration of things. It's really, really crucial to understand all of this, and especially this part here, like process management, process state, when is a thread kicking on, what are groups of current CPU instructions, and all of that. And besides this, we're gonna talk a little bit in this video about compilers, because you know the structure of a program. It has to be compiled, and then you need to run that in some cases. So if we start checking this, when you type in code, whatever language, can be Python or whatever, you have your source code. And I explained this before in my other courses, and there's a lot of resources about this, but this will be your source code. This is what you're typing, your functions, your definitions, your variables, everything is your source code. Keep in mind the machine doesn't know anything about this. The machine will only know binary or machine code, which is one level up. So whatever you're typing, your functions in Python or whatever, doesn't mean anything if they don't run in a process. And I'm showing you this as a refresher because efficiency is key for everything. If you're not doing a correct job of allocating things in memory, if you don't know how memory works, you're not doing a good job overall. So as a quick reminder, you do have your source code. This code is, again, your words, whatever you're typing. In the backend, all of this has to be tokenized, and then you need to parse that to some compiler. So the next step for this is a compiler. Now, it depends on your OS, depends on your language. Like there are many compilers for C++. Python will have depending how you install or where you're executing Python, but Python is compiling indeed. What the compiler does is it's going to transform, it's going to tokenize, it's going to transform pretty much your source code, your text you're typing in your computer, to a assembly stage. So after this, it's going to go into assembly. If you don't know, assembly is one of those keys knowledge to have as well. Assembly is a language. And it's basically kind of like the lowest level you can go by talking to a computer. You are sending the instructions from the GPU, you're allocating in memory, doing all those instructions and everything. An assembly needs an assembler to be able to work. The assembler will take that, because this is still unknown by the machine. We are structuring everything in order for the machine to understand and run this program. But at this point, it's still just it's still human readable, let's put it like that. If you haven't dealt with assembly before, there are many versions of assembly for your specific CPU architecture. So you need to dig around more on that if you want. But in this step here, the assembler will transform that into machine code. Now, this will create an object file. And you will see a lot of this if you're executing, for example, C++ programs. In Visual Studio, you can actually explore everything, or if you just compile it with a build system C++ code. In Python, all of this is happening in the backend, so you don't have to worry about this. Just keep in mind, C is kind of like the grandfather of programming languages. Obviously, Python was built with C. I don't even have to say it, but C++ obviously was built in C. Pretty much everything is built from C. The Linux OS, you name it. Obviously, Windows is by DOS and so on. But C will be the grandfather of all languages. So the more you want to gain knowledge, the better you need to understand these concepts. Maybe not in depth, if it's not your route, you don't want to go that route, but it's really, really beneficial. At this point, this is a file, which this file is carrying machine code, but you cannot execute this yet because you also need the next step, which is a linker. Now, in the production code, pretty much nothing is going to be just one file with code, because you're probably importing a lot of libraries. When you're importing, you're calling in from another file, and that's why we're installing, for example, pip packages or any other library. Just by having Python, you have lots of distribution of different files which you can call different libraries, standard libraries, like when you're calling time or whatever you're calling that from different programs, from different Python files or libraries into your main application. So you need to link all of those, and your program as well in production, you're going to split that. And again, we're going to check about design patterns and all of that later, but you usually split this, and then you need to link and communicate with all of these files as well. Keep in mind, all of this is also doing these steps because this is pure text, it's source code. So the linker will call in all of those. And also you have your OS libraries. So if you're doing like a graphical interface, let's say in Linux, you're probably calling the X11 SDK or whatever library, not just for graphics, you're probably reading files, right? You're reading something from your machine. So you always have to communicate with the OS. Even if you're not doing anything with your OS, this step is mandatory. So the linker will also receive that communication with your OS, and it's done via a kernel call. So after you have all of this, then here you will have your executable, or you can run this program. So a simple program like print hello, the most simplest of programs, maybe you're doing in Python just this function, print hello. If this is your main file, the print function is going to live in another library. So you're doing all of these steps. And as simple as this, it has to do all of these steps. So again, to drive this point home, you need to be familiar with this step. We are using a compiler. In Python, you can just run your program with a Python command, and that's it. But in the backend, all of this is happening. Now, Python is a dynamic programming language, meaning you don't have to specify type for the variables and all of that. But at the same time, it's abstracting too many things away from you. That's why it's considered super slow, and is one of the slowest programs to run. Now, lots of different new libraries and different versions of Python are making things even faster in pretty much like monthly updates. But keep in mind, the reason why it's faster is because most of the modern libraries are actually being built in C. Like when we're going to be using NumPy, and pretty much all the frameworks in AI are going to be built in C. but you are executing that in Python. And the reason for that, obviously, because Python is really popular, it's really easy to learn. The syntax is extremely simple. And that's why you're running C libraries, C programs, but with Python most of the time for modern frameworks and technologies in AI. And not just in AI, in a bunch of different fields as well. But anyways, that's why we need to prioritize making things efficient in Python, not just write code for the sake of writing code. Keep in mind everything's happening behind the scenes, and this is just for the compilation to be able to write code, compile, and run that code. There are many things you're going to check about memory allocation, containers, and all of that. And we're going to check that in the next videos. Okay, let's make this part 1 of data structure and algorithms. So data structure and algorithms. Why data structures? Because that's how you're going to deal with your data. Again, keep in mind everything is zeros and ones in a computer, just binary, which will translate to numbers. We can represent characters with numbers, and everything's going to be numbers at the end. It's important to establish that now, because again, everything in artificial intelligence is numbers, just numbers. Forget about images, video, audio, whatever. Everything is numbers for us. So in this case, we have different types of data structures, and depending on how you do and deal with your data and where you extract and, streamline or use your data in your application, it will depend how it's actually being structured in your machine. That's why it's called data structure. So we have structured data, we have non-structured data or unstructured data, we have relational data sets or relational data, and some other. But we have different, we will see about this as we go. But what is a structured data, for example? If you're dealing with some data that the computer needs to do something in order to actually process that data. So let's have an example. When you're dealing with, for example, configuration files, or your data is in a CSV file, which we're going to be using this a lot, or it can be, for example, a JSON file, which we're also going to be using a lot. This data is already structured. If you open a CSV file, it's going to be like an Excel sheet. We have rows and columns. That's why we're calling this structure, and this will also go in the category of relational. We will check about data really deeply later. For now, it's just about data structures, but JSON also has the structure as well, right? Traditional JSON structure, you have key value pairs, is an object, like an object in JavaScript or a dictionary in Python, and then you have your key and value pairs, right? All of these, it's called structure because it's self-explanatory, it has a structure, but it's not just visually, right? In the machine, something is happening. Keep in mind, all the data you're actually using can be, for example, in a cloud service, and a service is providing you the data, or it can be in your local machine. You have this data in your hard drive, for example, like this CSV file and JSON files and whatnot. This is living in your hard drive. When you're executing this, you need to store that in memory. So that's when, these processes and why it's important to know about OS, about kernels, about everything. So it's the same case, for example, when you have a program installed in your machine. Let's say this program is Houdini, for example, right? All the structured libraries, all the codes, all the compiled code and everything for Houdini is already in your hard drive. When you open Houdini, all of that is going to be copied in memory. So it will be memory allocations, and then the program is structured in your memory. That's why you can use it. It's not going to read everything from your drive. It has to be structured in memory. The same case when you're actually using your data. So if that CSV file is in some location here, it will also pass that into a memory allocation. So some chunk of RAM will have this. Now, why is it important to establish this between structured and non-structured or unstructured data? Because this data is already structured in the architecture of your machine, meaning this process of grabbing from your hard drive and allocate that in memory, obviously the CPU is sending those instructions, and there's a kernel in between doing that communication. So your CPU is you launch a process. Again, going back, that's why it's important to know about OS, about processes, threads, all of that. Your CPU is launching a process. It knows how to go into the hard drive. It knows how to access that structural program or the data you're grabbing, and it will allocate that in memory. But it's not gonna do that many instructions because this is already structured. So it's easier for the CPU. It's lighter instructions, therefore more performant, is faster to execute, and have that data ready in memory so you can use it. Now, if you have unstructured data, for example, like images or text, can be like random text or it can be like an image. An image is a matrix of pixel values, right? It doesn't have a structure like that. So if, for example, let's say you want to display an image, also the image obviously is stored somewhere in your hard drive. And you plan to use that image opening in your application or opening in Photoshop or Houdini or whatever. This is unstructured data, meaning the CPU, the kernel, all the processes for your OS will have to do extra operations to structure this data, to have the pixels in order of the matrix to display the image correctly. It has to do a bunch of processes, and then it's going to allocate that in memory as well. And then you're going to do the next steps. Again, the kernel is communicating now with your graphical card. So there will be your GPU. A bunch of processes are happening here. Kernels are being called, a bunch of different things. The data is being structured in memory. And at the end, you can display that in your monitor, for example. So those are the main differences. And we're going to be dealing with both structured and unstructured data. We're going to go deeper in data a lot later, but this is just like a high-level overview. Now, when you're dealing with this, let's say in our production, we are dealing with CSV files. Maybe it's a data set for something we're trying to do. Either it's going to be like exploratory data or we're actually using it for a machine learning model. This is the current data we are using in production. So this will be known as the production data, right? You are using this one right now. And maybe you're doing a bunch of experiments and then you're creating your machine learning model. And maybe let's say you need to jump in the next task or something like that. This is the production, or sometimes it's also called the operational data set because you are using that one right now. If you're not using it anymore, you jump into the next task. Maybe this one, you're gonna store that in the servers of your company or in your own servers. But this one now goes here, and then you jump into a new data set. Let's say it's a new CSV file. And then you keep doing that over and over again. So if you keep track of this, maybe you have a data set from like 10 years ago in your company or maybe in your job. And maybe you need to extract patterns of the data being stored in your company of past data, which is not the operational or production data at the moment. If you need to extract those patterns, if you need to dig around in your data set, this is known as a data warehouse. Now, to extract those patterns from your data warehouse, we're going to use machine learning algorithms as well. And we're going to do some practices about this. But these are just some bare common concepts you need to be familiar with in case you haven't seen them before. But it's really, really important to know about memory. And we're going to check the next videos about memory. We're going to dedicate a whole video about that. But keep in mind, probably RAM, one of the most important components, because we're going to be dealing with containers pretty much in the entirety of this course. So this is just a really, really high level quick overview in case you're not that familiar with these concepts of how data structure. Obviously, there's a lot in here, like all different algorithms to structure data, how it's being allocated, what kind of instructions is your CPU sending for this, and it's really important. Before we dive deeper into memory, let's just do one more concept in this video. And one example that's very common in programming, using the most basic container, an array. Now, in Python, that's called a list. As I said before, Python is a dynamic programming language. You don't have to specify, like in C,
If you're doing like a variable, you need to say this is an integer, a or whatever name equals 10. In Python, you can just say a is equals to 10. And it will know this is an integer variable. And later you can change that. You can say a is equals to a string, right? There's a lot of issues in type safety and a bunch of other things. But if we start dealing with this will be data types. This is an integer, this is a string, and so on. The way arrays will work in Python by default, they will be dynamic. If you know about vectors in C++, for example, it's a very similar case. So it will depend on the compiler how it's been allocated, but as a rule, it will do it something like this. It will depend on the compiler and the Python version and how are you using it. But let's say you're creating a list in Python and you have some numbers, 1 and 2. Now, these data types, which in this case they are integers, they will be stored in memory. Depending on the architecture, we're gonna check about that in the next videos. I'm just gonna do some really quick concept here. Since this is dynamic, Python will actually allocate in memory extra spaces in here. It will depend in some conditions how many, but it will allocate some extra spaces in here. Even when this container just has 2 elements, you are filling in your memory with nothing pretty much. And the way this works and the reason why this is working like that is because dynamic arrays mean you can expand them or you can shrink them as you like. You can modify and mutate these arrays whenever you want, which is a double-edged sword. Can be really dangerous sometimes and non-performant, depending how you're allocating things in memory. And the reason for that is you need some extra space in case you need to allocate more elements into this array. So now let's say you're going to allocate 3, 4, but you also need to allocate 5, for example. Now we don't have more space in here. What the compiler is doing in the background is going to copy all of this into new memory allocations. It's basically going to copy all the array again. You can imagine how many CPU instructions you are sending by doing this and how much memory you are using. And it's going to allocate maybe 2 more spaces. Now you can allocate 5, right? And maybe you need to allocate now 6 and 7. So the same thing happens again. You want to copy all of that, create new spaces so you can allocate this. So you need to be careful when you're doing these kind of operations. And in data science, in machine learning, you're going to be dealing with maybe millions of data entries. I'm just showing you tiny, tiny small arrays. But keep in mind everything that's happening behind the scenes. And in Python, you can also use fixed arrays, not just lists. And you will sometimes prioritize using static arrays with predefined, pre-allocated memory because it's going to be way more efficient. Now, in terms of function calls and the call stack for everything happening behind the scenes, we also need to keep a track on that. But more on that, we're going to check it in the next videos. Okay, let's talk about memory for a second. Now, we know about data types, right? Integers, floats, decimals, characters, strings, and so on. Obviously, we can also define our own data type if we have a class or a struct. Lots of different data types. Now, this will depend on the OS and on the compiler. But let's stick with integers, for example, and they will have their differences about memory allocation. But let's assume we have a common compiler, and let's say usually when we have, for example, a 64-bit architecture in our computer, this will mean the structure being used by the RAM and the system. So if we start drawing this, for example, we're going to have some allocation. The smallest unit will be a bit. You can think on a bit as a switch. So this will be off or can be on. And that's why the computers work with the binary system. yes or no, on and off. 0 for off, 1 obviously for on. Now, this in hardware will be a transistor, right? Think about this as a LED, right? Tiny light is going to switch either on or off, which if you combine this will allow us to do mathematical operations. That's why everything in a computer at the end will translate to numbers. Now, it's important to know the binary system, at least a little bit. So the numbers we use in a daily basis, any number, this is the decimal system, meaning this is base 10. For computers, everything we do will be base 2. So all the operations like logarithms, everything will be base 2 because of the binary system. If you're not that familiar, let's do like a table. Again, usually in decimal systems, we are base 10, but in base 2, we will start this by 1, 2, and this is of the power of 2, so that will be 4, 8, 16, 32, 64, and so on. Okay, so let's say we're trying to find the number 19 in binary. If we start with this quote-unquote table here, we can start doing that definition. So the way we're going to find out what's the representation of 19 in binary, first of all, we're going to jump into the closest number, but that is not bigger. For example, if we jump to 32, 32 is bigger than 19. So we know it's not going to be any of these numbers. So we're going to prefix that with zeros. So it will be zeros all the way through the end. And usually we denote this, for example, as 0x. Now, we know it's going to fit in here in 16. So we're going to add a 1 in here. And then we're going to add to the next number. So 16 plus 8, that's obviously going to be greater than 19. So we're going to add a 0. 16 plus 4, that's 20, which is also greater than 19. So we're going to add a 0 as well. Now, 16 plus 2, that's 18, right? Which is not bigger than 19. So we're going to add a 1 in here. At this point, the sum we are carrying is 18. So I'm going to put it here. And we're going to keep doing the same. So 18 plus 1 is not bigger than 19, is equal to 19. So we're going to add a 1 as well. Therefore, 19 in binary will be this. And it will be 1, 0, 0, 1, 1. And we can verify that. We can Google this. Let's search for 19 in binary. And is equals to, yeah, you can also denote as B, but you can see 1, 0, 0, 1, 1, which is what we have here. 1, 0, 0, 1, 1. And you can try that with any number you like. So this will be 19. So we can represent also, you know, the compiler can represent characters as numbers. So all I'm saying here at the end is that everything will be transformed in binary for the computer to actually perform operations. Now you should know about binary operations. In case you don't, I would suggest you to Google that. We're not gonna go deeper into that, but you know, we have the, actually we can do like a really quick version here. So let's say we have another number. I don't know which number is this, but let's say we have 0, 0, 1, 0, 1, 0. So we're dealing with this. So bitwise operations. Bitwise operations are really essential because again, that's how a machine works pretty much at the end of the day. And with bitwise, it's self-explanatory. We're doing operations on the bits. Remember, each one of these will be a bit in a computer. So this one, this one, this one, this one, and so on. Now with these bits, you know, we have the AND gate. The AND gate will establish that if the numbers are both 1, the result is going to be 1. So if 1 and 1, they are both 1, the AND operation will result in 1. So this will be equals to 1. You can see here, these are not 1, this is 0 and 0, 0 and 1. So the only one in here, if we're doing the bit operation AND between these two, it will be at the end. Let's do that. 0, 1 and 0 is going to be 0 because they are not both 1. 0 and 1 is also 0. 0 and 0 is going to be 0. 1 and 1 is going to be 1. And 1 and 0 is going to be 0. You can use this for lots of different useful things like bit masking, trying to do some kind of masking operation and stuff like that. Now, the OR operation is going to set each bit to 1 if one of the two is 1, right? So it's not the same characteristics as AND. It's enough if one of the numbers is 1, the result is going to be 1. So 0 and 0, that will be 0. 1 and 0, we have at least 1, 1, so that will be 1. 0 and 1, the same. 0 and 0 is going to be 0. 1 and 1 is going to be 1. And 1 and 0 is going to be 1. Okay, the OR operation. Again, it's going to depend on what you're trying to do, what you need to use this for, but we use bitwise operations all the time. Now, XOR. This is going to set each bit to 1 if only one of the two bits is 1. So it's similar to OR, but will only do if one of the elements is 1. So in this case, it will be 0. This is correct. Just one of these is 1. Just one of these is 1. These are 0. These are both 1, so it will be 0. And just one of these is 1. That XOR. And these are, at least to me, one of the most useful operations we do. I usually think about this as a gate in terms of like you're closing the gate if the numbers are the same. As you can see here, every time the numbers are the same, 0 and 0 is going to be 0. So you're kind of like negating that. Also here, they are the same, so it's going to be 0. But when they are not the same, it's going to be 1. And there are more bitwise operations. You have NOT as well. And basically these guys have their operator. So AND is this, OR is the bar, XOR is the caret symbol, and NOT is the tilde symbol. And NOT is used to reverse the number. So for example, let's say we have 0, 1, 0, 1. If we NOT this operation, it will be the opposite. So zeros become 1, 1 becomes zeros, and so on. Sometimes really useful as well. Also, we have the shifting operators. So this will be shift to the left, shift to the right. And we also have something called zero fail shift, which I don't use it that much, but these ones are definitely useful. So if you have a number, for example, the original one we have, which is 010011, which is this one here. If you do a shift to the left, we are shifting everything 1 bit to the left. So 1 will go instead of this 0. So this number, if we start doing that operation to the left, will be 1, 1, 0, 1, 1, and basically we are swapping this. We're moving this one here, we're moving this one here, and so on. As you can see now, the first one is empty. Whenever this is empty, this is gonna fill in with a 0, and this operation will negate that 0. But this is bit shifting, and this is gonna transform, and you can create lots of arithmetic mathematical operations by doing this bit shifting. And the same thing to the right, right? So for right shift, it's gonna be the opposite. We're gonna start shifting numbers to the right. So this one we're gonna shift here, this one here, this one here, and so on. The one that stays left is gonna fill in with 0. So basically we're gonna prefix this with zeros. Obviously this number is gone. So extremely useful as well And the way this is gonna work in memory, now we start talking about allocating data types like these ones here in memory. So let me create one of these, a new one. What we have is, let's start just dealing with integer types, right? Let's say we have some number. We don't know which number, but we're gonna allocate this in memory. And remember, this is in binary. Again, we're gonna start with checking if this is like a 64-bit architecture in our machine. This data type, whatever it is, we have a variable, something of type integer. Again, it's gonna depend on the compiler and the OS, how much it's gonna use in memory. But we start allocating that in bits. So it's some number. We will have the first number in here, for example, 0. That will be 1 bit. The characteristics of this structure is whenever we have 8 bits, that equals to a byte. 4 bytes will be 32 bits. Therefore, 8 bytes is going to be 64. Right? So let's do a byte here. 0, 1, 1, some random number. Right? We have the 8 bytes. So we have filled the first 8 bytes in our RAM, in memory. 1, 2, 3, 4, 5, 6, 7. We need another one. Sorry about that. Now we have 8 bytes. So we have allocated this in memory. It can be a really long number. But remember, these are 8 bits, which is equals to 1 byte. Okay? We need 4 bytes for 32 bits. So in memory, it's actually going to start allocating in this direction. And this is called the endianness of the memory. And you can investigate further about that. But basically in here, it's going to allocate 8 more bits. Let's say our number ends there. Actually, let's say this number is 0. So our number kind of like ends here. But we still need to allocate all of this, right? So the next 8 bits will be full of zeros. 4, 5, 6, 7, 8. Now this is 2 bytes. We're still a long way from 64, right? So we need to keep allocating this. It's going to be the next. That's going to be 3 bytes, 4 bytes. And we need to do all of that until we have 8 bytes. So all of these are full with zeros until we match our 64-bit architecture. Why is structure like that? Because of the precision. Because you can have a long integer or a long float number, and you need, just imagine like in rocket science, sending a rocket to the moon, you need absolute precision in every calculation. So we're dealing with lots, big floating point numbers or integers. So that's why you have this. Now, this can be extremely overkill in RAM, in memory, if you don't use it efficiently, because maybe you're doing some calculation of IDs or something like that, that you don't need 64 bits. Maybe you just need 8 bits. Like just this first part. That's why libraries powerful as SciPy or NumPy, you can do these operations. And as you can imagine, it's not only more efficient in memory, CPU-wise, the calculations will be way cheaper if you just have 8 bits. But you having this trade-off of not having lots of precision, right? A lot of times in data science as well, we have other concepts such as bfloat. We will check about that later. And you can just use maybe 16 bits, just these two, which could be enough for your calculations. And you don't have to do overkill memory allocations with pretty much nothing, all this empty space full with zeros, but this is allocated by the system, meaning you cannot use these memory slots, and therefore you're using unnecessary RAM if you don't do things correctly. That's why it's important to know about memory allocations, different data types, different data structures, and so on. Okay, we're here in the branch Computer Basics, and let's start checking about some data structures and algorithms. This is going to be the first part of our Python refresher. In case you're not that familiar with Python, you should be if you're taking this course, but it's just a quick refresher. Very basic stuff, the most basic stuff. And then in the second part for this Python refresher, we're gonna dive into the production concepts. I'm gonna create super quickly a basic application following some production principles. But in this first part,
let's just check about some containers. So I'm gonna call in this file like that, and let's just start doing some basic stuff. You know, the most basic list you can have in Python is gonna be a Python list where you have some elements. This will be an object. By itself, you are calling in from a library from a predefined class. So if you print, for example, the type of my list, and you just run that, it's gonna be a class of type list, right? You're gonna be using that one a lot. And you can use the methods from the class. You know, you can append, you can delete, and do a bunch of stuff. You can extend, and so on. Lots of things you do with lists, regular lists in Python. But you also have regular arrays, and you can import that. For example, if you import array. Now let's create an actual array. Let's call this one my array, and it's going to be equals to array.array. And the syntax for this is a bit different. You need to specify the data type. And for the second argument, you can either create a list or you can pass a list. We have a list, which is my list. Now, notice here, I'm creating integers as my elements for my original list. And in my array, I'm passing that as the argument for the array. But f will mean this is going to be a float. So in here, for example, we can print my array. If I do that, you can see it converted the integers into floats. Now, which one you want to use? Most of the time you will see a list because, again, Python is being developed a lot. It's going to be more performant. It has some memory trick behind the scenes, but I will definitely advise you to prioritize using arrays if you know beforehand how many elements you need in the array. If you don't know, you can always use a list because an array is going to be more performant. It's going to be more memory friendly. So it's up to you. And obviously you can do the methods again for the array. You can append to the array, you can delete elements from the array, and so on. Now, for the next part here, let's start checking about some common containers we're going to use, especially in AI. Now, I'm going to call the default list in Python, I'm going to call this one an array, so we don't get confused. So from now on, I'm going to call it an array, but it's, a Python list. So if I create a regular array in here, same as before, you have an array and some elements inside. So right in the container itself, you have your data types and your elements. This will be 1, 2, 3, 4, 4 integers. This is one-dimensional array. And every element inside is known as a scalar value. Now, in AI, you're going to be dealing with all sorts of multidimensional data. And we're going to check that in a second. But if I do this, now you can see the array contains another array inside. So the first element is maybe this, and the second element is another array. So this is an array of arrays, which is, missing a comma here. This is a two-dimensional array. And you can see why, because it's an array of arrays. Now, we can have more dimensions than this, but this is still an array. So the more core fundamental data structure we're going to be using in machine learning is a tensor. So let's call this one tensor, and let's create a tensor in here. If I do this, this is a tensor. This is a valid tensor. Let's call this one T2. And if I do this, do this again, this one and this one is the same. We can make it more clear. This is also a valid tensor. So sometimes a question is, what is an array and what is a tensor? If you check online deeper, the denomination of a tensor will be a multi or an n-dimensional container.
And we don't know how many dimensions we're dealing with, but it's a multi-dimensional container. But again, this is also a tensor. Now, why multi-dimensional? As we're dealing with data and features, we can have an infinite amount of dimensions, and we will check some examples about that. But there is a difference between arrays like these ones and tensors like these ones. And it's all about kind of like the rules you follow. If I do this, let me remove this one and let me remove this one. We just have these two, which are, at this point are basically the same. But if I do this, let me insert another element in here. This is still a valid array or a valid list in Python. You can do operations, nothing is breaking the program. This is a valid list. But this is not a tensor. A tensor has to be homogeneous. What that means is for every element, they have to have the same number of elements. Like this one here. You can see the first element is 1, 2, 3. That's 3 of length. And the second element is 4, 5, 6. That's also 3 on length. This we know, and this will give us the shape of the tensor. Shape, one of the most fundamental pieces in machine learning, again, or in a bunch of fields. What's the shape of this tensor? If we follow this, we have 2 rows and we have 3 columns. So the shape of this is 2 by 3. And that's the characteristic of a tensor. It has to be the same number of elements for each one of the containers. As you go in dimensions, it's gonna go exponentially more complex. So if we have something like this, we need to have also another element in here. And that will make it a 2 by 4 tensor or a matrix. That's the main difference between regular arrays, which can be anything, can be even different data types and everything. For us, tensors will have to follow that rule. That's one of the main core fundamental units and data types data structures we're gonna use in machine learning. We're playing with tensors all the time. And that's why it's called TensorFlow, that framework. But everything will narrow down to this as we structure everything. And why is a tensor? All the inputs we can possibly have, audio, video, images, you name it, we need to transform all of that into numbers for a machine. But that's just one of the steps, and we will check about this later. But tokenizing or doing some representation of the data in a numeric form is what we want. But that's one of the first stages. There's always a stage to convert those numbers into tensors. Because once we have the data in a tensor form, that's how machines can actually learn. We can tune these values, we can modify them. And that's why one of the most important mathematical operations in AI is matrix multiplications, or dealing with some kind of mathematical operation for matrices. Because these are the values we can tune, we can change, we can find the best patterns, and this is how machines learn. After that, it will do the opposite conversion of transforming it into a numeric data and all the way up to a final pixel, for example. So it's very important to have this in mind. Other data types you should be familiar with, definitely, obviously, apart from these kind of containers, will be graphs, linked list, all sorts of tree traversals, binary tree, binary search trees. If you don't know about those, you should definitely investigate because they are extremely essential. And one of the most useful as well is going to be sets and dictionaries. So if I do some variable here, that's a valid set. And to these, you can add values, right? Similar as a dictionary or a hash map, they have to be unique values. So if we do some hash map, some dictionary here, you know, it's conformed by keys and values. And the value of one of these can be an array or a nested dictionary. Really, really handy. You're going to be using this especially in the form of JSON files and API calls. We're going to be creating an API at some point, a really simple one, and checking some production concepts along the way. But these are just very basics. We're doing a Python refresher here, and this is like the extreme basics of Python. In the next videos, we're gonna go really quickly and try to create some application to check some production concepts, because with those production concepts, we're gonna have in mind, we're gonna be dealing with all the rest of this course. Remember, even if you're a freelancer, you need to think in teamwork. Everything's gonna be either supervised by someone else, or it's going to be different stakeholders, many different people working in different features of your application. If you want to grow it exponentially, you want to make it scalable, you need to follow some standards, some rules. So it doesn't matter what we do, little experiments or not, we're always keeping that production hat in mind, and we're going to follow those rules all along the way. Okay, let's start talking about solid principles. We're going to view also some design patterns, something you should definitely Google if you're not familiar with that. Design patterns, very standard and very vital to know in an engineering role or anything tech related. It doesn't matter if you're a game developer, if you're a VFX artist, solid principles and design patterns are absolutely vital for a production. Now, let's start checking solid principles. Now, even when we did like tiny, basically nothing of a Python refresher in the first video, just talking about some containers, you should be familiar with OOP, Object-Oriented Programming. It's something extremely standard and is the way any program works. So just purely based on that, I'm going to assume you already know, but the solid principles, sometimes people don't know about this, or you don't have this in mind all the time. But let's start checking. Solid stands for single responsibility, open and close principle, list of substitution, interface segregation, and dependency inversion. It's one of these quote-unquote rules you need to follow if you're developing a piece of software. Why? This with design patterns will go hand in hand. If you want to make some code that is going to be production ready in terms of modularity, in terms of scalability, you need to follow these principles. Otherwise, you're not doing a correct job. It's badly developed, and you will never do that in a production. So let's start checking this. Single responsibility. When you're creating a class and you're instantiating objects from that class, you should follow this. Now, responsibility is not, sometimes people get confused about this, is not what the class should do. It's not like the class should only be responsible for one thing. We're talking about changes in this case. So if you see this great example here, let's say you're creating a character class or you have some sort of user class. And then if you see this, it will be a bad practice if you create an engineering policeman class, right? The best way of taking this approach will be to create a class, and then your objects will be either engineer or policeman. So when you're an engineer, you will do engineer things, and when you're a policeman, you will do policeman things. Because probably your parent class is a human or an employee or a user class. So if you think about this scalability, just in this principle, you can have other multiple types of characters. Like you can have a doctor, fireman, you name it. If you do it this way, you're really closing up your code for production because you're an engineer policeman, so it's not ideal. The open and close principle. A class should be open for extension but closed for modification. And this is a great example here. Say you're doing a class for a car. You have your base class, but then you're hard-coded in your class that the cars must have 3 wheels or 6, 3 on one side, 3 on another side. And you're doing all your development. It doesn't matter if this is like a futuristic game. A car is a car. You need to think in that level of abstraction, because you probably need that for not just your own same game if you're doing a game or a movie, possibly for other projects, possibly for all the future projects or your entire company or even multiple companies. So obviously in those other projects, maybe your car, it doesn't need to have 3 wheels on one side and 3 wheels in the other side. That way that class will be useless. And this is like this perfect example for this. And you can see the class, it's open for extension. So you can add new parts for the car depending on your requirement. Maybe it's a different game, maybe it's a different movie, and so on. But you're not hard coding, closing yourself something very specific that's going to cause problems down the chain. For all of this, always think in modularity, reusability of your code. Risk of substitution. Can't replace its parent in eating meat. So this one is one of those cases you really need to think in the higher level of abstraction of a class. In this case, it wouldn't be advisable to create, for example, an elephant class and then a lion class. Because if you're doing this way, first of all, it's not reusable, right? Think about, as I'm saying, the top level of abstraction. The best way of doing this will be to create a parent class called animals, for example. And then as you derive that class, you will have subclasses. So you can be an elephant, you can be a lion, it can be a monkey, it can be whatever you want. But in this case, what this mainly refers to is when you have that relationship. So for example, in a better example like this one, and this is very clear as well. If you're doing it like a parent, like a human parent class, you have lots of things the parent has and the parent, what the parent can do, right? So the parent maybe has a name, has an age, maybe has a job, and maybe can do parent things like maybe buying a car, buying a house, and so on. If you straight up take that class and create a derived class, a children, like a human children of the parent class, you're inheriting everything that the parent can do, which is not realistic, is not ideal, is not production friendly, and is not correct overall. Because you're inheriting everything, and keep in mind, a children, like a toddler, maybe has some common things, like the children can also have age, name, but maybe can't have a job, right? The children can't like just buy a house, stuff like that. So now your code is wrong because it's just inheriting from that parent class, grabbing everything just for the sake of inheriting. So again, a better workflow for this is to create a parent class. This can be a human class. And when you're a kid, you can do kid things. When you're a parent, you can do parent things. The main topic of this is in the main abstract class, the top class, you're defining the contract. So everything that the subclasses should have and should do. But the derived classes will dictate how they should do it. So in the top class, for example, you can say, okay, my humans can have name, age, and so on. But when you're a parent, you can do parent things. And when you're a kid, you can do kid things. So let's move to the next one, interface segregation. This one is, if you see the example here, why are you forcing me to take gum? And then the correct way, you should never be forced to take anything. For example, let's say you're doing a video game and you have your character class. It will be a bad practice if you include in the character class, maybe you have a payment system in your game. Let's say that payment system is in your character class. It wouldn't be ideal because if you need to use that character class in possibly another levels, another game, you're not going to use the payment system. You just need the character itself, right? So imagine having something like that. You're forcing the user to have that even if you're not going to use it. So this principle stands for that. How you can separate all your concerns, all the parts of your application. So you only instantiate or quote unquote borrow that class with the stuff you need, nothing in there that you're not going to use. And the dependency inversion, you can see this is a great example. I can only code with Java, and the correct way will be I can code with any programming language. The dependency inversion, if you see it in the tree form, if you have your top class, maybe it's like a human class, and then you have a bunch of derived classes, maybe for employees, maybe for different kind of things. If you keep doing that, maybe you're deriving a class from the derived class and so on. You can have a big tree, but if in all that chain, you have some hard-coded dependency that either the top level changes or the very leaf class changes, it shouldn't break anything in that tree. If it breaks, you're violating this principle. You shouldn't have, if you go from bottom up or top to bottom, you shouldn't break anything if something changes. And this is what this principle stands for. You see, these are production rules you need to follow in your code. All the code you're doing all the time should follow this. And these are just the solid principles. As we do our quick application, we want to check about design patterns. There are many design patterns. Obviously, we're not going to check them all. I will advise you to check as much as possible, because again, it's some of these production concepts that will go hand in hand with all of these solid principles. But we're gonna do a shopping cart application. Let's say we're working in a store, and the logic follows through everything: game development, a VFX shot, you name it. It's just, again, a Python refresher, and we want to check some concepts as we quickly do that class. Okay, we're gonna do a quick small application with some production concepts. This is just outside of AI for a second, but in general it's all about engineering and how you work in a production and how you should think about structuring your code all the time. We're gonna talk a bit about design patterns. Now, design patterns is a big topic. The main concept on this, and you will use this all the time in the production, but the main concept is reusable logic instead of reusable code. Obviously, we are reusing code, we are making modular, scalable code all the time. But the main logic is about reusability of ideas, of the logic itself. That's what design patterns is all about. If you Google, you can find all about design patterns. It's a lot, it's a big topic, and there are many design patterns. Obviously, we're not gonna talk about every single one of these, but ideally for a production, you will need to be familiar and really familiar with all of this. Just look for design patterns in Google, and then you will find pretty much all the info you can possibly have. Lots of different cool stuff, and there are many types of design patterns again. And you've probably been using this a lot. So as we do our small application, we're going to start talking about some of these design patterns. But quickly, I'm going to draw something that why you need design patterns in the first place. Imagine you're doing some sort of class, some sort of application. Let's say you're doing for a bank, or kind of like what we're about to do. We're going to do a shopping cart class for a store. But if you have, let's say, a game, which is your main product, you're developing a game, right? Everything's in here, and then you're doing your classes and all of that. Now, imagine, like we said before, let's say you have some sort of platform in your game, like a fancy UI and stuff like that. And then, for example, this is some of the logic before starting the game, where you have some kind of payment system. You have some store, like actual money in your game. You can buy character props, you can buy new clothes, and so on, a bunch of different things. So if you have your game logic and you're doing your class, I'm going to abstract all of this away. For example, you have a game class, and then maybe you have some methods that you can start the first level, and a bunch of things going to trigger here. Maybe a boss, maybe your level itself, like dynamics, a bunch of logic in your game. And you're also implementing here in the game class the payment system, right? And a bunch of other stuff. Maybe you need to communicate with bank APIs, with crypto APIs, whatever. And you're doing a bunch of things here in your game class. This will be really bad, because at the same time, you're going to violate a lot of solid principles, as we talked before. So let's take a look at the payment system for 1 second as one example. So let's say you have a method to do the payment system, right? And in here, maybe you have an amount, and maybe you have the currency and some other parameters you can have, right? So in a bad design for a piece of software, for an application, or the methods or the classes you're dealing with, if you have everything in here, for example, let's say the user is going to pass that some currency in, let's say, USD, right, in dollars. You will pass that, and then you also have the amount, let's say $5 or something like that. What happens, let's say you have a check here, and then you do if the currency is equals to USD, you're gonna do some logic, right? And then maybe you have another payment method. Maybe your application is growing from outside USD currency countries, and let's say now you're in the UK, so you have another if statement. If the currency is equals to British pound, you have the logic again, maybe another logic. And then you immediately see why this is not scaling well. What happens if your game is really popular and now you need to expand to 50 different countries with different currencies? You'll have a bunch of if statements. If this is equals to maybe Canadian dollars and so on. And then you have a bunch of if statements in here. This is really terrible. This is not scalable. And this is why, and this is a little example why you need to figure out something different than that. And for example, in here, we're gonna check a design pattern called dependency injection. So, and again, it's one of many, many design patterns. So dependency injection, this will stand for whenever you create the logic of an object is not where you're gonna set the object. So what I mean by that is you mean to create the object somewhere else, and then you're gonna call in that object in a different class. So for example, the better way of doing this will be you have a different class just for the payment system. Now in this class, you have your attributes and you have your method, right? Maybe you have a lot of methods in here. This class by itself is handling the payment system. So you have a whole team dedicated to the payment system. And in your main app, in your game, you just calling in the payment system wherever you need to call the payment system. So if the user wants to do a transaction or something, and then you're gonna call in the payment system. And the payment system will be an instance of that class. So in your game logic, you should have a function, maybe the better version of this, where in the parameter itself, you're gonna receive here an object. That's the main concept about dependency injection. So you're just passing in an object, and the object has all the power from this class. So if you need to expand your currency, and remember those solid principles, the team can keep expanding this, right? Via configuration files and stuff like that. So it's not gonna be a bunch of if statements. Probably if you ship in your game, let's say to China, your team in China, they just switch a configuration file and then all the logic is gonna work. Therefore, all your game is gonna work. That's the main concept about dependency injection. You're injecting in your main class a dependency of another class. So you have a full class that handles the payment system, all the configuration files, logins, everything you need to do. And maybe in this class as well, you have another dependency injection. And maybe in here, you're expecting an object, let's say, for configuration files. Maybe all the logging you're doing here is doing like in a JSON file. So you have an input-output class, which you can define as another class. So now you have another class that is in charge of, for example, reading and saving files. So transaction records, all of that you have in another class. And you're gonna inject that in this class. And this class, you're gonna inject that in your main game, right? You see how this works? Because now you have a whole team here can be in charge of doing that IO, input, output, for different files. Because maybe your Chinese clients, they wanna use, let's say, CSV for the register of the transactions, or some other way they already have that in line. So you need to open that as much as possible. And maybe when you're shipping this for the US, for example, they will have another method. Maybe those clients are working with JSON files, or they have their own in-house transaction records. So it's up to them. You're just gonna switch these configuration files, whatever is your client, and everything should work. And then you have teams working on this, on these methods for the class, and another team doing the logic itself for the game. And this is just one example. Again, this is just one design pattern called dependency injection. There are many design patterns. Usually the main one I work is called the repository pattern, which is kind of like a similar logic, but they do have a lot of differences. So I will definitely recommend you to check design patterns. Obviously, we're not gonna check every single one of these, but it's important for you to know in a production, you will be dealing with these kind of scenarios all the time. So in repository pattern, for example, you will have your main application again, let's say it's this one, and then you have this structure of repositories that are handling different parts for your application. Let's say all the UI stuff is being done in this repository. And then you have another one for the logic for a payment system in another repository. And then you have, let's say, the logic for network communication you're dealing with a multiplayer game. So you're splitting this in different repositories, and this is called also the separation of concerns. As you're working in these repositories, your main game, your main app, we're just gonna call this whenever the game requires. So one of the main differences will be that in the repository pattern, these are individual projects. So this is one project, and doing UI stuff is another project, which now you can see how you can reuse that, because maybe you're doing game number 2, or another part of another team is doing that. They can still borrow things from the UI repository, so everyone can connect in between. It's kind of like this modularity effect of working in a team, especially. Another game can be calling in all the payment system, because payment system maybe is not for games, maybe it works for different products as well. And you're making modular, reusable, and scalable code. So that's enough for a high-level overview, and then we're gonna jump into going hands-on. Try to go quickly and try to establish some sort of production techniques for a Python project. Okay, let's jump into our little application. Let's start doing a diagram again with my horrible drawings. This in production, you will have some platforms like Miro or different kind of diagram platforms where you actually do this. And you will be presented with a lot of this, and will be like this iterative approach of starting your main application, your main idea. But as a simple production techniques, everything is going to be in a repo, which at the end is a folder structure, is a directory, right? This is your main app that we're going to do. Now in here, we're going to have subfolders. So I'll explain the project a little bit. This is a shopping cart. So a shopping cart for some kind of like store we're trying to work with, or your game, or whatever you're doing. Now keep in mind, this is not just for shopping carts. The logic itself can be anything, can be a machine learning product, can be anything. So, but we're gonna do a shopping cart. Now, in the main structure, in your folder, we're gonna have some subfolders. One subfolder is for the shopping cart itself. We're gonna have another folder for tests, because we're gonna do a unit test. And in the main core structure, the root, we're gonna call all this the root. You're gonna have some configurations as well. This is where we're gonna store our database. Now you can also store the database in a folder. For now, we're just gonna keep it at root, because maybe we're gonna change that. Maybe potentially we're gonna do something else. In here, we're gonna have our main. That's gonna be the main Python file that's gonna run this. Is it just a test? It's like examples using the shopping cart. This will be your user, and there are examples actually using the class. We will have at root the requirements. For this, we're not gonna use external libraries. We're just gonna use one external library, PyTest, for the unit test. But this is where you have the requirements file, very common. You see that in GitHub repos all the time. We're gonna have an empty, which we're not gonna use now, setup.py file. And why we need this? In case you need to package all of this as a pip package, which sometimes is required for your production. In that case, it's a whole different structure you need, but it's necessary to have it. Even when you're not using it, this is like a common production structure. Having subfolders for your different classes, having a main stage where you can execute and test your class, having a requirements file so the user can install all the dependencies, because maybe you are using external libraries, and a setup.py if you need to add instructions to send this to a pip repo, to a pip package. So that's the main structure. Now inside shopping cart, this is a directory. Let's do another arrow here. We're gonna have an init.py constructor. This is an empty Python file. We need that if we need to call in this folder, the shopping cart folder, as a module. We need to have that. In here, we're gonna define our cart class. We're gonna define the file input output. We're gonna define the item class, because we need items in our shopping cart. And if we need some other extra utilities, we're gonna keep adding them here. So in your main app, if this is just for the shopping cart, if this is a store, the application is for a store, maybe you need more classes, right? This is just for the shopping cart. But let's say if we expand this, maybe now we have an employee or a user's submodule. The users, maybe they also need to log in some information so they can use the file IO. See how we make it modular and reusable? Maybe they also need some kind of item for their own items and so on. So it will communicate with their own structure of the class, basically. So let's start doing the structure for this. In here, I'm in the computer basics branch. Let's just create a new folder. Let's call this one shopping cart. So if I cd in there, this will be our main structure. And let's start creating some of these structures. So we're gonna make a directory. Let's call this one shopping cart again. Like this. There we go. We have two folders, shopping cart and tests. And let's start creating some of these files. If this is your GitHub root, you will have the README and everything in here. For now, I'm just gonna create the files. So let's have main.py. Let's have requirements.txt. And again, if we need to, we're gonna use that. So this is the main structure we have. Main, we're gonna be testing our shopping cart. Requirements will be for the users to install. This is gonna be empty for now, but we need it in case we need to create a package from this. All the logic will be inside shopping cart, and test will be for the unit testing. So let's jump into creating we can start with the items class. So inside shopping cart, let's create some files. Again, we're gonna use init.py to have this as a module. So we have that empty file. We also need, for now we're gonna be empty cart.py. It's gonna be for the shopping cart. This one's gonna be for the file input output. And we need for the item. And let's also do some utilities. We will need some random numbers in order to have random IDs, either for items or users. We need some random utilities. So let's call this one random number utils.py. There we go. We have some files inside the shopping cart. Now we can also split this further. We could have subfolders, one for the items and so on, but I don't want to make a mess and a maze here. So for now, we're going to keep it like that. But remember, in your production, it might be required for you to actually have some predefined structure. So maybe it's mandatory to have in proper folders. And there will be some documentation in your production showing you the required structure. So you do have some requirements. For now, we're going to assume we're going to have here all the files we need. So again, if we go back here, this is our root. For me, it's this one where we have the main file requirements set up. We have the folder for shopping cart and we have the folder for test. So let's jump here again and we can start doing this logic. So let's start with the random numbers. So for this, what we need, we're gonna import random and let's also import string. We're gonna need some utilities from that. Already we are using libraries. These are default Python libraries, so you don't need to install anything extra, but we're gonna keep importing stuff. So let's define a class in here. Call this one random utils. You can add doc strings for the class. Let's call this one class for generation of random numbers. And you can keep adding more the more you expand the class. Now, we're gonna use this as a static method. This is regular Python stuff. You should be familiar, but basically it means you don't have to instantiate a whole class in order for you to just use this method. We're gonna keep in mind dependency injection. We are creating a new class for random utilities. We need to generate some random numbers for the IDs in our items, right? So that's why we're separating a new class to create that for us. So all of this class, and this will be team members, will be working on this. You don't need to call in a class, instantiate the class in items if you just need to pass this as an object. That's why we have a static method. So in here, let's call this one generate random ID. Again, this is static. We don't need to attach this to the class. And the result for this will be a string. Again, in your production might be required for this to be specific, like an integer or something. For now, we're just gonna assume this is gonna be a string. So let's do a docstring here. So this class, this method will generate a random ID number of length. Let's have it 6. Again, maybe this is required for your production. And obviously this is giving you an issue because not returning anything, and returning a string is mandatory. So let's take care of that. In here, we're gonna return, we're gonna join, and what we're gonna join is, we're gonna have random that choices. We're gonna have some choices here. And the choices we want is, this is where we're gonna call in the string method that ASCII. We can have uppercase. Again, I keep saying this, but maybe in your production is required to have an ID with lowercase, uppercase, and so on. And k will be equals to 6. And you can pass that as an argument if you want. But this is gonna generate some random characters as an ID, and it's gonna be unique. That's why we need that. Now, again, this class here is gonna be responsible for generating random things. Can be random strings, random numbers. So maybe in other parts of your production or different games, the IDs for the user has to be like floating point, like a float data type for some reason, and so on. So your team can come back to this class and keep expanding that and add more methods. For now, we're just gonna use this. This is a class by itself, is just in charge of generating random IDs. Perfect, we have that. Now let's go to our file input output module. So in here, this is the team members, these are the team members in charge to dealing with file input output, to read files, to output files, whatever you want. And we can expand the class as we want. As the example, maybe some clients will require this class to export JSON files or CSV files and all of that. For now, we're just gonna keep it as JSON files. And we need the OS, and then from here, we're gonna start using data classes. If you haven't dealt with data classes before, I would recommend to check some YouTube tutorials. We're not gonna go in depth about this, but we're gonna talk about a little bit for a second. So from data classes, we're gonna import data class, and we're gonna import fields as well. So why data classes? If you're doing a class from scratch, and again, I would recommend you to check in depth about this, but you're doing some kind of class, right? You will have to define everything in here. So if you want to print the class, you have all these magic methods to, for example, the wrapper to represent the class, right? And then you can return a string in here. So if you print the instance of that class, it's gonna print this, because if you don't have the wrapper method in your class, if you print your object, it's gonna give you an error, right? You can't just print an object. While if you have this inside your class, if you print the instance for this class, it's gonna print some string or whatever you're passing in here. And the same type, right? If you have some numbers in your class, you can do this. That way, if your object has numbers, maybe has an age, let's say you have user A 10 years old, and then you have user B 5 years old, you can say user A plus user B, and the result will be 15. So you can add objects, you can add classes, but you need to do this all by hand. And if you are doing lots of operations with your classes, it's going to be like a complete maze. You have to keep going back to your class and doing many different of these. If you use data classes, comes like inbuilt with lots of functionality for you to not even worry about this. So in production, you will see this a lot. We use this at work all the time. So if we have this as a decorator, and then your class in here will be, for example, let's call this fstream, like C or C++. this class will be in charge of dealing with the data IO. So, and it's going to be a data class. So it's going to come with lots of those functionalities. And the way you deal with data classes will be in this pattern. You're going to have your class members, your attributes in here. You're going to have some sort of path. It's going to be a string. You're going to have the extension, also string, because again, maybe you're dealing with JSON files, with CSV files, and so on. Let's also have a data file attribute. It's going to be a string, and you can give it a default. So if you add here fields and set this, for example, to false, it's not going to be initiated as default all the time, because maybe your class, if you give it, let's say, JSON by default, it's going to be kind of like painful, because every time a client is not going to be using specific JSON data, they have to change it, right? So in this case, we're just going to have a false as a default for the field. Now, in here, we're going to have this as a class method. The same way we were checking static methods, in this case, you don't have to instantiate an object and then call in that object and so on. You can just call in the class, that the name of the method, and you can just straight away just call in the method. This is mainly for organization purposes when you have class methods and static methods. It's mainly like you don't want to have loose functions in your code. No one will do that. But if you see you have a function that you're using all the time that has some sense with your application, maybe that can be a static method. But in this case, this is a function that has to be, like, it's mandatory to be part of this IO app class. That's why we sometimes split this in class methods or static methods. So let's keep going with this. It will make more sense. So this will be a function to load JSON files, right? Because we are dealing first with JSON files. Now this is going to be a class method again, so you need to specify CLS, and we can return here. We're going to return a dictionary. You can specify the types in there if you want, and let's give it as usual a docstring, right? So what is this method doing? So this method will read a JSON file. So read JSON files from a directory. And we do have some arguments in here. So usually in docstrings, you will see the part for arguments like this. So what are the arguments expected for this? You need to give it a path. So this will be the path for the JSON file to read, right? And then what is this method returning? You will see it in this way. So it's going to return a dictionary, and the dictionary will be, it's just a hash map with the JSON structure. Always keep in mind this production concept. Clean code, really understandable for the rest of your team. Your team can really know what this method is doing. So we're gonna open the JSON file here, and we're gonna have the path, whatever path we're parsing in, we're gonna read the binary. And this will be as data file, right? Now, the data file, which when you're calling this class or instantiating, is kind of optional at this point if you're using a class method. We can just switch this, instead of being false by default or none, we can have the JSON file itself. We will have a JSON file where we're gonna be writing and reading the data. Because just imagine for a second, like a store. Let's say you're doing your Amazon shopping cart. You're adding items to the shopping cart, but maybe you didn't bought all of them yet. And then you just close that, and then in the next day, you go back and continue. So it will be terrible if you just exit the website and all the shopping cart is gone, right? We're trying to have a better experience, so we need to save all the data from the user, every click they're doing and all of that, and we're going to store that in the JSON file. That's why we need this. So this will load the data file, and since by default this will be converted to a Python dictionary, we can just return that. So we're going to return the data file, and that's it. This is what this class is doing. This is going to load JSON files. If it's required for your production,
to load different files, you will keep doing that in here. We can still do that. A class method, we will call this one load CSV files, for example. You see the logic for that? And maybe you're expanding more and more, and this is dedicated team members expanding this class. Maybe you need to read now XML files, really common in VFX houses, and all that great stuff. So for now, we're just gonna stick to this, but let's have one more method here. This one is gonna be a static method. And again, the difference will be that loading a JSON file is mandatory for this class. We're dealing all the logic for that. Maybe you have a method that makes some sense to have it in a class, but it's not kind of like mandatory. Sometimes the logic plays like that. So let's do a function here. Let's call this one print JSON, or print structures, we can call it even. Not just JSON, but let's just keep it like that. Now in here, we need to pass in some sort of data file, right? And you can also give it a docstring if you want. I'm just gonna keep it simple. You get the point. You should always have the same code style. If you are in docstring in one method, you should always have that in your other methods. For now, we're just gonna keep it like that. So if we have the item, this will be keys or items in the dictionary. So that will be in the data file. And we're gonna call in, this will be a very specific structure of my JSON file, which I will create in a second. If you call in items, there will be key value pairs, and we can just print those. We're gonna print the item. You can also print the ID if you want. In this case, we're not accessing that, but in fact, let's print those. That should be the ID and the item. See this? This can be in a better production way. This should be just print structure or print structure of a file. I'm gonna keep it like that for now, but you get the point. Print structure of a file is maybe not absolutely tied to this specific class, because maybe that method can be used in different parts, but you don't wanna have this method, this function, lose in some way in your code. We are structuring this. That's why this is a static method. So that's our IO, and we can start checking the item class. All right, let's start working in the item. Item, the abstraction meaning your product you're adding to your shopping cart. So let's think on the logic for this. What are the characteristics of an item? The attributes. An item, let's start with the basics. So it can have a name, it can have a type, maybe a category. Obviously the price is one of the main elements, and it will have an ID. Even when you have, let's say you're adding two of the same items into your shopping cart, the IDs will always be unique, right? This is kind of the logic we are implementing as we develop our application. If we need more stuff, we're gonna add it. So maybe it's required that your item has a category by color or by size. Maybe you have the weight in there as well. Lots of different things. We're gonna keep it simple, and this is how I usually structure and start my code. Core functionality first, and then you keep adding that in the refactoring stage. Now, remember, we are dealing with data classes, so we're gonna do the same. From data classes, we're gonna import a data class, and we also wanna import a field if we're required to set a field, which we will. Now, the shopping cart folder is a module because we do have the constructor in there, init.py. So we can call in from shopping cart that random number utils, because if you see, for a second, let me go outside. This folder we are in, the shopping cart folder, we do have the ability to call it as a module for this, and we have this file in here. So we're gonna call in shopping cart that random number utils. So that's what we trying to implement here. Now in here, we're gonna import random utils, which is the name of the class, if you remember. If you have more classes with randomization in that file, you will just call them, and that's how overall Python works. So this is gonna be a data class again, but now this time, let's give it some common security concerns about this application. And again, this is when we come back and think about the logic.
Usually all of this logic we are writing, we are thinking, I'm trying to go faster, but usually in the production, again, you will have a document, diagrams, drawing all of this logic. In this case, for example, you don't want any user to change the ID of an item or change the name and so on. You are defining the class, but the user should only use the class. So in that case, for example, and this is when you start checking in regular OOP about your access modifiers. In data classes, we can establish this to be frozen, meaning is read only, right? All the members, all the functions and everything in this class is gonna be immutable. So I'm gonna set order to true, and we're gonna set slots to true as well. That way we're gonna keep all our security tight, and now we can start defining the item class. An item can be anything, whatever product we have in our current store. So we're gonna require a name. Let's also give it a type, and let's give it a price. You know, in Python, if you set it with underscore, this will be private, and this is gonna be a float. Now the default for this, let's give it a start of 0.0. It's gonna be a floating point. And the ID, this is when we're gonna start using our random utils. It's gonna be a string. We're gonna pass in as a field, and if you wanna pass in here a function, which that's why we have the random utils, we have functions inside, we just have one, but if you have more, that's gonna generate our required random IDs, right? So the way we're gonna call in this, if you pass in default factory in the field argument, we can call in that utility we want. Again, that's the reason we were setting that as a class method, because otherwise, if it's not a class method, you need to instantiate something here, right? You need to instantiate random utils, and then maybe you need to do some other operation. If you don't want that, because we are using dependency injection, we can just straight up just call in this that generate random ID. And we know that's going to return the requirement we need, which is a length of 6 as a random string, all in uppercase letters. Perfect. Now, another way of defining these methods will be if we set this to a property, and we have a method for the class. We don't have to call this, if this is a property, as a function. So I'll just do here an example. Let's say we're using this in another file. We will have to instantiate a class, and then we have access to the method. And then we have to call in price as a method. But if this is set as a property, you can just call in like that, as you will call any of these attributes up here. But it's a function. You can do lots of logics for a function, but you just call it like this, as a property. Reason we're doing that, many reasons, we're gonna keep organized, and later functions, later methods in different classes, maybe they don't accept functions, right? They just accept as an argument. So potentially we need to restructure this. But for now, we're gonna keep it like that. And the reason we're doing that, the reason we're doing it as a function is because for this particular shopping cart, it's required that the price has 2 decimals. So if the user is having input lots of decimal points, this is gonna convert that, and maybe for your requirements, maybe it's 4 decimal points as a floating points and so on. In this case, our supervisor said all the prices has to be of length 2 in the decimal points, in the decimal places. So that's why we have it as a function, and we don't want to call a function all the time. That's why we are setting this as a property. So the price itself of this object will always have all the requirements we need. So we're gonna round this, and we're gonna read the price we have. And if you specify here as 2, it will be 2 decimal points. So self that price is the price for this current object. And obviously I have a typo, that's why I was complaining. There we go. Sorry about that. And actually, let's have this as another property too. this is very common in production. Again, you're gonna assign a search string to this item. If you keep in mind, for example, let's say YouTube videos, they will have a description given by the user and so on. When you're searching for that video, usually those objects have a method like this, where you can query this object by the search string and you can define which search string the object will have. Maybe you have a long description. Your search string is really short, so it's gonna be easier for the overall development of finding this particular item. So we're gonna return as an f string self.name, which is the name of the product, and self.type. Maybe we need to restructure, depending on the requirements, the search string. But if we are searching for this object, maybe we have lots of different attributes here. Remember, this is an item. We can have weight, we can have all sorts of different characteristics of attribute. Maybe you have like 500 different attributes for this object. You don't want to have all of these in your search string. Maybe you can structure this depending on how you need it. But this is all for the item class. Really simple, using data classes as usual, making sure it's immutable, so not anyone can just modify these values. And we have some functions defined as properties, so we can just call them as we call a regular attribute. So that's item. And now let's do the main one, which is the cart class. I'm gonna go a little bit faster, because it's gonna be a bit long, but still following the same logic as we need. Now, what are the requirements for our cart? The user should be able to get all the items that the user is placing in the cart. The user should be able to search for an item. The user can be searched for an item in the cart or in the store. The user should be able to get the total count of items. Obviously, the user should be able to add items to the cart, to remove items from the cart, to remove items by selection, by name, you name it. To get the total price so far as adding to the cart, the user can also empty the entire cart and so on. Now, our database will look something like that, like this, before even doing anything. We're gonna have an initial key in here, like this. I'm gonna call this items. Actually, it was capital, right? And the key for this will be, for example, the first item. So inside here, you can have, for example, this will be some random generated ID. Obviously, we are following the rules, everything capital and so on. And inside here, we will have the characteristics, right? So we have name, and then the value of the name. Maybe this is like, maybe this is a fruit. So maybe this is an apple. And then we have the type. So it will be fruit. And then let's say we have the price, and this is a float, and so on. We can have more. For now, we're gonna keep it simple, but the structure for this is gonna be like that. We have the item, ID of the item, name, type, and price. This is how everything is gonna look in our database. So for the cart itself, let's start by, we know we are reading JSON files. Let's start doing data classes as well. This is going to be a data class. And to keep consistency. And now we can start calling in all the previous stuff we did. So from shopping cart, that item, we're going to import item. This is the name of the class at the end. And this is the name of the Python file. So from shopping cart, that random number utils, we're gonna import random utils, everything we need to import from the previous steps we did. So from shopping cart, that file IO, we're gonna import, it was fstring, there we go. All the different classes, we have access to all those methods and all the great stuff. The main class for the cart will be another data class, and the class is called cart. Now, we need a path to the database. Call this one database path. And it's going to be a string. We're not going to give it any default. We need some booleans as well. to keep track if the card is empty or not. Maybe we're not gonna play around with this too much, but just in case, let's leave it there. It's gonna be a bool. At the beginning, it's gonna be true because we don't have anything in the card. It's active, maybe. Again, maybe we're not gonna use this, but if we need to, they are in there. At the beginning, it's not active, and we can have also an ID for the card itself, not just for the items. And now you can see how we are reusing different chunks of our code. Not just the items are using the IDs, because maybe we need IDs not just for the items, we need IDs for the user, we need IDs for the shopping cart. So we are reusing our modular code. And this is the beautiful thing about design patterns. The default factory for this will be the same we did before, random utils that generate random ID. There we go, we have an ID for our shopping cart. Let's start by defining the getAllItems method. Attach it to the class, and we can have some verbose if we want. So usually if you add in print statements or some kind of useful login information, you will set that as a verbose. We're gonna have one, and the default will be 0 or no verbose. And if the user sets this item as 1, you will have all the information you need. So let's also give it a docstring reads and returns hash map with all the available items. There we go. And always a good idea to add all the possible instructions in here. Remember our arguments. In our minds, we know if we set this to 0, we're not going to have any login info. If we have 1, we do going to have, but we need to specify that to the user. So if verbose is set to 1, it will print all the items. And you can always specify the returns. What type? It is going to return a dictionary, and again, it's just a hash map with all the items in the database. Cool. Now let's do the logic. So our data file, what we're reading is, this is going to be equals to, when I start using our modular reusable code, that's why we're doing all of this structure for design patterns, reusable modules and everything. When I use loadString and when I use the load.json files method, if we need a different requirement to load CSV files, another part of the team will be in charge of adding that functionality in Fstream, and we're just gonna use it here. So ideally, Fstream will have that method integrated. Instead of load JSON files, it will load CSV files, and we can even specify here what kind of file extension we are trying to use. So this is going to require the self.database path, because obviously we want to load our database. Now let's do some housekeeping. If the length of this data file, that items, so remember this is a dictionary, is greater than 0, I'm gonna set this to false, because it's not empty if we have higher than 0 elements, and we can make it active as well, so that will be true. Then we can have the logic for printing or getting all the items. So let's do that in the try block. So if verbose is set to 1, we know we can print stuff, right? So that will be fstream, and we have the functionality to that. We don't have to create anything in this class. We're just using functionality from other classes we created, and we already have the print JSON structure method in that class. So we can just print this, and we can return that data file, because remember, we are returning this. We need to return a dictionary. So if that doesn't work, we'll do an exception, and we can raise a value error. So we can give a message here like value for the variables has to be 0 or 1. So what happens here is if the user, instead of setting 0 or 1 for the variables, maybe they have an error or some kind of mistake, they pass a string or mistype or something, we're going to return that. So it has to be 0 or 1. And in this case, we should also return the data file. So what's happening in here is if the user is not setting variables to 1, so it's leaving a default of 0, you're still going to get all the items. So maybe you can do something else, right? Because potentially you don't want to be printing it all the time. And only if the user sets this to 1, it's going to print all the items and then return the data file. Otherwise, it's just going to return the data file. Sometimes it can be annoying to have forced print statement. That's why we are structuring this like that. All right, that's get all the items. Now let's do the functionality to search items. We're going to attach it to the class. And we need a query, which is going to be a type string. Now, this is going to return a list of items. Item, the class we define. So basically, the user can query for some item that is searching for. And as usual, I'm not going to do it here, but you add the doc string, setting all the arguments, what this function is returning. So I want to go a little bit faster, but you get the point. Usually structured as this all the same way we did before. Now, our data in here, we can also call in loads from JSON files. Usually, think about what's happening here. We already did this up here, but it's not like the user is doing this function here, and then it has to do this other method or function here. They are independent because the user can be searching for items. They don't necessarily want to get all the items. So that's why I'm doing that here again. If you're doing both lots of times and it's required for the user to have both, you will have this outside. Maybe you have another method in the class or an attribute that's gonna read this. That way you can set this one time and you don't wasting computing resources. You're not wasting any extra computation because every time you call in this, it has to do all that JSON structure in memory. It has to read it again. It has to do all the different processes. So we're doing that once here and doing the logic to get all the items. And then we're doing that same thing again in here. But these are independent. So we don't know if the user is going to do this. A better structure for this will be, for example, maybe we can have this in this as an outside function, depending on how we need. If we need to prioritize performance, I will definitely keep this guy outside. Just keep that in mind. And again, usually at the beginning, we're just doing the first pass of the logic of our application. The main concern right now is that the functionality is working. We can do everything we are saying here, get all items, search for items and whatnot. In a later stage, which I'm not going to do, but you can do that yourself, it will be the refactoring stage, checking performance, making sure you're not doing unnecessary computation twice or even worse, more times that you don't need to. For now, we're just going to keep it like that. Now, we are reading here the data, so we have all the data set. Now, let's have a list here. I'm going to call it matching items. And as we query for this, we're going to be adding the items to this matching items list. So let's do a loop. For item ID, which are the keys in our hash map, item data, which is the content in data. Remember, we always start with items because that will be the items you have. Maybe you have different things in our data set. That's why we're keeping it like that. Items will be the methods from Python to check the key value per items from the dictionary. So in here, the item will be equals to item. And let's pass in everything we need for the item. What are we doing here? Every time we are finding this, a structure in the JSON file, we're going to create a new item class. And that object, we're going to pass it into the matching items list. That's why the return type is a list of type item. So what do we need? We need the name, that will be equals to whatever name we have in our database. So that will be item data, and we pass in the name. Right. What else do we need? We need a type, and this is structured in our item class, so we need to follow that. That will be item data type. We also have a price, which will be equal to item data price, and the ID will be equals to item ID, because that's the value we have in the loop, the main variables, the pointers we have in the loop. So we are creating an item class like this. We have an item now. Now, if query, which is whatever string the user is passing here, let's keep it lower because maybe the user is not necessarily tracking all the uppercase and lowercase. We're gonna do the search string. So that's item, that's search string. That's why we created that. And remember, that's a property. So we can call it like this. You're gonna use the search string also as lower. And basically this means if the user is passing something and that something is present in our search string, the search string, remember, is the representation for each item. That's why it's really important to have that in there. We found the item, so we can append it to matching items. We're gonna append the item. Awesome. Now, once we did all of that, if we do have actual items in here, so if the length of matching items is 0, meaning we don't have anything, we can just print no items found or no item found. In that case, else for item in matching items, we're gonna use some f string, and we found the item, so we can pass in item.name, whatever we need, whatever requirement again we have for this. Maybe we have item.type, and let's just give it the price. So we can have maybe a $sign here and item.price. Remember this? We are not calling in the original price, the attribute of the item object. We can call it like this because we have a static method in that class, and this is a function in the backend. The user will only know, or your fellow developers, the price is like that. But what were the requirements in our main architecture? It has to have 2 floating points. So all of this in the backend is calling a function that's going to do that. Maybe you have other extra requirements. You don't have to do a function, a variable, then assign that, then pass that here. You can straight up call it as an attribute. That's why we're using static methods. That's why we're using class methods and so on. So it's really powerful to work like that. At the end, after we have all of that, we're just going to return that list of matching items. And that should be our search items method. I'm going to quickly add the rest and come back so we don't waste too much time doing that, but it will follow the same logic. All right, we're back. So we did the get items method in here. We did the search items method. I introduced this one, for example, get total item count, doing some doc strings, and this is just returning, again, reading that. We have a return type, that's why we did it in here, get all items, and we just returning the length of that. So this method will return how many items we have in total. We can add items to the cart, and you can read the doc strings. We are getting the data. Again, one of those cases, maybe all of these, which we're doing a bunch of times, can be just one method in the class that we're gonna handle that. For now, we worry about functionality first. When we have this, we are setting a new item structure. It has to match all the structure we have in our dataset, in our JSON file. And then we will assign that to the proper key. So we will have an item ID. We know how we are generating those and everything. and we will set a new item. And in this case, we are dumping in the JSON file. So we are writing items into the cart. We are setting this, and we just print some login for the user that they know they added an item successfully to the cart. We can remove all the instances by query. This is just some random stuff I was adding. For example, let's say you're passing in a type or a name. So let's say you have a big cart, but now you don't need to buy any liquids you add to the cart. So you have vegetables and so on. So you can say, okay, remove all the types by liquid, and it's going to remove all of those from the cart. In this case, it will mainly be by name and by type. But you can add more logic into this. Again, same thing we're doing all the time. Potentially, this is one flag to improve performance, to keep just this as ones. And obviously some housekeeping. If you're trying to remove something but the card is empty, it's going to give you an issue or a warning. And then just the logic to do that. Basically just doing looping through that, checking the matching queries we find in our dataset, and it's just going to delete that from the dataset. And at the end, it's just going to update the JSON file. Also, we can do that by selection. So this is just going to enumerate all the items we have. It's going to start at 0. That's why we're setting this as 1. So the user will have an option. Okay, you have 1 apple, 2 toy, 3 laptop, and so on. You can choose remove item number 1, and it's going to remove the first one, or whatever number is assigned to that. So, and it's going to give you some examples here. It's going to expect user input. If you're not doing a correct choice, passing something else is going to give you a warning or an error. It's going to raise a value error. If it doesn't find the item, it's going to print item not found, and so on. Very, very simple stuff. Getting the total price of items, we can have the access to the prices we have for all the items, and we're just going to add them all, and we have that as a result. And we can just empty the cart, basically wipe the entire JSON file. And that's pretty much it. So I'm going to do quickly the main and come back again so we don't waste too much time. It's going to be extremely simple, but I'll come back in a second. Okay, I'm here at root. Let me show you the database first. Let's say a user was doing this cart yesterday. So they're logging in again into the app and checking the state they left the cart before. So this is how the ID looks. And they have the product. So it's an apple, let's type fruit, the price, and so on. So this is a very, very simple database, but we are dealing with a database. So in main, what I did is importing the classes I need. Again, remember, this is now you testing all your program. All the structure, modularity, all of that are in the subfolders, classes, methods, and all of that. So we have the item class, we have the cart class, and we're just calling in our main function in here. And you can see some of these comments in here. The database will be this file, the one I just showed you, database.json. And for cart, we need to pass that one. So we are instantiating an object of this class, and we're passing in the database. Now we have a fully functional my cart object or a cart object. So in here, I'm just testing the methods we have. So print searching item, because we are searching an item. So we'll have a variable result, and we're calling in the search items, and we are searching for apple in the cart. Same thing here, getting the total amount of items we have. This is creating an item so it can be added to the cart. We are instantiating new items. So we have a new item, milk, type liquid, and the price. And then we're going to add that to the cart. So we are instantiating, we are creating an item, and we are adding items to the class. Same thing here. Same thing here. Now, getting all the items from the cart, using our functions, we are removing an item by type. In this case, we are removing by type milk. If something is of type milk, we can have lots of different types of milk in our cart. It's going to delete all of them. And in here, and remember, this is going to wait for a user input to remove something by specific selection. So you have like a menu, getting all the current items in the cart and getting the total price you have so far in the cart. So we can start testing this. Probably there's going to be lots of issues, but let's just check it. Oh, there we go. So the program is running successfully. So searching for an item, we were searching for apple and it found an apple in our cart and it's giving us whatever we are setting as information. So that's an apple, it's a fruit, and that's the price. How many items we have in our data set? 3, that's correct. I show you the JSON file. Now we are adding items to the cart and we have a login. We have added milk, we have added onions in the cart. We're getting all the items in the cart. You can see here IDs, they are unique. And then we have the structure we specify. We have apple, type fruit, price, we have banana, type fruit, and so on. And remember, we created these items and we added the new items to the JSON file. Now, next step, we are removing all the types of milks. Obviously, we just have one. If we have more, we will remove all of those. And in here is telling us, and this is wrong, it shouldn't be 0. We don't have a 0 entry, but which one of these entries, and if you take a look at the structure, it doesn't have milk anymore because we just removed it. Which one of these we want to delete? Let's delete the last one. So we're going to choose 4. And then it removed the onion from the cart because that was number 4, if you see here. And now we have just 3 items. And the total price, adding them together, is 106. So everything is working. Really quickly, we're gonna use PyTest. Just make sure you have installed PyTest for the unit test. And I didn't have it. So in requirements, you should add that. If you're using a library and installing that, you should add the name of the library here. If you're using a specific version, you will add the version in here. In this case, whatever, if the user is using the latest one, that will be fine. If you have other libraries, you should name them in here. Because when the user is cloning this repo, all they can do is pip install -r requirements, and it's going to install all the libraries listed in requirements. So in our case, if we're doing unit tests, we just need that. In my case, I'm going to do it here. And again, I'm going to do it really quickly because I don't want to be like half an hour writing code, but I'm going to do that super quickly and come back again. Okay, I'm inside the test folder. Just to remind you the structure, this is root. Instead of going to shopping cart, we are in tests right now. Now, for the test, I have, again, so we can call this as a module, I have the constructor here, and then we have test cart, we have a test database, and test item. PyTest will know where to go. It knows how to go into this folder, and it knows it needs to execute everything starting with test. This is a common naming convention in production. So every time you're using unit tests, the file needs to start with test. And we have a test database because obviously we don't want to test in our main operational data set or database. So we need kind of like a mock database for the test. If I show you that one, it's just this. It has an apple and a pineapple. So in case you're not familiar with unit tests, the way the architecture of a piece of software will work is something we call the pyramid architecture. So as you can see, your application can grow really, really big. And you need to do some tests of small chunks of that code, right? You need to test some specific functions, some specific methods, some specific instances of objects, classes. So you're testing your codes in small chunks. We refer to that as unit testing. So we're going to do that now. And PyTest is a library that is going to allow us to do that. Again, why are we doing that? If our application is really big, you need to keep tracking all the functionality into the different small or functional sections of your application. Because maybe, as we did the example, maybe we have, let's say, a payment system in here. And we are splitting the payment system into further smaller code. So maybe some teams are handling, let's say, crypto, like Bitcoin or Ethereum, and actual currency like USD and so on. Maybe something happened in our code that specifically, let's say, Ethereum is not working, right?
That's why we need to run unit tests, all the possible case scenarios in our application, try to break, quote unquote, our application. That way we know everything is working as it should work. If some of those cases failed, we know we have a problem. So that's like the main reason we do that. And in terms of the software pyramid architecture, the way you're going to implement this in production and the way you usually deal with this is you're doing unit tests. After that, you will enter something called CI/CD, which you should be familiar with this. But how are you going to integrate this in the flow of your application? Remember, this is a cycle. Lots of feedback and potentially changes we're going to have here. So how you run this automatically. Some companies will use, for example, GitHub Actions or some in-house architecture to deal with these cases, how you deploy that into the next stages of the production. Because this needs to go into different departments, and we have designers doing the front-end UI and so on. So it's a constant flow. That's why we have custom integration and custom deployment for this. But you will start testing that, the in-house integration. You will go in and go like this, that's why it's called the pyramid. Then you go into different stages of testing your application. And at some point you will have your feedback and go to the bottom again to restructure this. But anyways, not to go into further detail of this, let's start checking this. We are in the very first step of doing unit tests to make sure every single piece of our application, all those modules, all of those pieces of code, all the design patterns, all of that is working. So if we test, for example, the test card, or let's start with the smallest one. Let's check the test item. We are, as usual, importing this from all the modular code we did. So we are importing the item class. And if you see here, all the functions that start with test, PyTest will know how to handle that because it's going to do some fancy terminal stuff we're going to see in a second. But you should always start this with test. PyTest will know, okay, that's a unit test function we're going to test. So what are we doing here? We are testing if the price method is working for our item class. So let's take a look at that. We are creating a new item here. It's a car of type vehicle and we are setting the price. I'm just making up numbers. Now, for all of this, I did an assertion step. So we're going to assert here. There are many other types you can have in PyTest and unit test. To keep it simple, I'm just keeping it as assert. So what's happening here? This is going to be true, the condition for that, or it's going to be a positive test if item.price is greater or equals to 0. Because a car, for some reason, can be free, right? Maybe you won it in a contest or something. So 0 is a valid number for the price for a car, right? And also we are giving it this specific number. So if this evaluates to correct, this test is gonna pass. Why this is useful? Because imagine if we are allowing negative numbers in our application. That wouldn't be correct. 0 can be a valid number because again, an item can be free for some reason. That's valid, right? But you can't have negative numbers in here. That way, if this pass, we can assume this price, test item price, which is a function we are defining this for PyTest, will evaluate to correct. So we know that functionality for the item is good. Again, we're gonna test names for the items. We are instantiating a new item here. I'm calling it as one length, as one character, A of type B and some price, right? And we are checking this if the length of an item is greater than 0, which is, this is valid. An item can also have, if you think about reality, it can also have one character as a name. It's not invalid, right? It's not great, but it's not incorrect. So if for some reason in our application we did a mistake and we didn't pass anything as a name, so it's a string but it's empty, it wouldn't be correct. It will fail. In this case, we are checking if the names are greater than 0 in length. It's going to be valid. So if we want to deploy our application, let's say it's just this class with just these methods, right? In our system,
we should have some sort of detection that only if it passes all these cases, only if this unit test is correct, then it's going to self-deploy into the company. Back in the day, it used to be a manual process of some supervisor checking if this is working and then approve the next stage. But in the concept of CI/CD, it's all about automation. We should have something that's going to detect in our company, in our pipeline, that the unit tests are successful. That way, it's going to auto-deploy that to the next stage. That's why we're doing unit tests. Now let's check the cart test. Obviously, we have lots of methods in the class, so we can do this a little bit better. So importing PyTest. In here, I'm just, and if you notice, I didn't import the PyTest before, but in this case, it's because I'm going to use this specific fixtures decorator. So I'm just importing what I need from my modules. And what this is going to do is basically, maybe this is just for performance, right? Because as before, I don't want to do this every time I'm doing each one of these, instantiating or creating a new database and so on. So this class here, you see the cart, this function will be in charge of doing that just one time. So we are doing that. We are instantiating the class we want, and all the following will be just the test. Notice this one is not starting with test. So PyTest will execute that, but it knows it needs to perform the unit test only in these functions because they start with the word test. So anyway, this is going to create a new cart class, and then we do all the testing we want. So what's the first testing we're going to do? Test total price of the cart, right? Inside, this is all dummy data. We're just testing the code, testing our functions and everything. We are creating two items. One is an apple, or can be whatever, but we have two items. And then we are testing if this is going to be successful. So in order for us to have the prices on the cart, we need to have the items in the cart. So that's why we are using the methods we have in the cart, right? We are doing that test. We're adding item 1, we are adding item 2 to the cart, and then we are calling the method we did in the cart class to get the total price of items. We know by seeing this, if this is price 2 and this one is also of price 2, the result should be 4, right? So this is why we have an assert here. What happens if for some reason we do this, we call in this method, get total price of items, which we establish, and we don't have 4, maybe we have 5 or 6. This assert will fail and this unit test will fail, right? Telling us something is wrong in the logic of adding items, because we are hard coding here. We are telling the program you should be 4, and if this is 4, we're gonna have a successful PyTest. That's how we debug and test our code. Same thing for this. We are testing if the cart is empty. Remember we did the empty cart method in the class. So adding one item, adding the item to the cart, calling in that method, it should be of length 0, right? So that's why we're doing this check here. And if this is doing all of that, which is gonna do at the time we run PyTest, it's gonna instantiate, add the item to the cart, empty the cart, it should be 0. So if this is 0, the assert will be positive, so this is gonna pass. If not, this is gonna fail. So something is wrong in our empty cart function, and so on. So you can see I'm doing a test for searching items. This should be returning tomato if we are searching for tomato. We are testing getting all items function, and so on. So you can read the code, but basically that's why we do a unit test. So in order to run this, if you go here, so if you go into the root, which is this place, all you have to do is type PyTest. And you can see this. It's testing all the unit tests that we have inside, because we did unit tests for the card and we did unit tests for the items. As you can see, this is green and it's telling you all the 7 cases we established there, which is a combination of both, have passed. This is green. If some of them is failing, this will be in red and it will show you there. and it will show you some really fancy logging where in the application is the issue. So you can see all the logs. It collected 7 items, it's testing this file, it's testing this file, and all the cases pass. So this is great. If you're setting this in your CI/CD pipeline, it will have a green light to move forward because everything is working in your code. So this is very simple, but is the main structural logic we will use in a production. All right, I'm here back on my Mac. I'm gonna try to stay here. And when we need to go into Windows, Unreal Engine, and a bunch of other things, we will go there. Once we need to train models, you can by all means experiment if you want in an Apple Silicon machine if you have one. Lots of frameworks and libraries are adding compatibility for these specific chips. It's not going to be the same experience. It's very experimental and it's not that fast as dedicated GPUs, especially with CUDA cores, right? So regardless of that, we're going to check some experiments. Again, if I need to train some models using parallel processing, I can go into Colab and do that, or using some sort of cloud computing, or B, I can SSH into my Linux machine, which has a dedicated GPU. With all of that in the side, we're going to check this library really quickly. We're not going to be using this library along this course, but it's very beneficial for you to understand it. NumPy will be the core library for everything we do here. And we're going to check it NumPy in the next videos. The reason we're checking this first is because potentially you will use it in a production and it's very, very useful. So this library is NumPy on steroids. It's adding a lot of extra processing, parallel computing, and a bunch of different things. We will check just the simplest one. But you can go ahead and install JAX. You can see the command here. It's usually a pip install JAX. If you have a GPU, you will install it with the CUDA version, as it says here. So obviously I'm going to test it in my local Mac, so I'm just going to use CPU, but still it's going to be more powerful than regular NumPy. Another one you might want to check will be SciPy, which this one again will be NumPy on steroids. But SciPy, or Scientific Python, will be this release of this library, build architecture on top of NumPy, but it's going to have way more precision. So if you need something with absolute precision, like medical fields, astrophysics, and so on, like architecture and many other fields, you will probably use SciPy instead of using NumPy. But for most things, NumPy will be enough. And a lot of things you will come back to NumPy anyways. Now, NumPy is only CPU based, while JAX can be both. It can be parallel processing in GPU or just CPU. Regardless of that, you're gonna switch to the branch. So I just cloned the repo. We are here in the computer basics branch, and I do have some Conda environments. And this machine, you can see here, I did create one for JAX. So let's jump into that environment. If we go into JAX, I should have everything I need here. Now we're gonna create a notebook. So I'm gonna open VS Code. You can use Jupyter Notebook if you want, and I'm just gonna open that folder really quickly. So for me, in some specific place is this folder here, and in VS Code you can switch to your branches as well. You can see since I'm in my terminal and my environment, it went to that branch automatically. So perfect. Let's create a new folder here. Let's call this one JAX, and we're just gonna check some experiments. So let's do a notebook. Let's call this one JAX intro.ipy ND for an IPython notebook. The kernel is going to be one of our Python environments. Obviously, you have to match everything you're doing in the terminal and all of that. So for me, it's this JAX environment. So there we go. Let's start just adding some simple things. We're going to do it really quickly. Again, we're not going to use this library in the course. Maybe we're going to do some experiments. Primarily, it's going to be all NumPy, but it's useful to know. So import JAX.numpy, and you can already see this, how they are actually building this as JNP. As a standard, let's install whatever is requiring for us to install. This is a brand new environment on my machine, so the first time you run it, you need to install some packages if you're using VS Code. And there we go. Let's run this again. The kernel is connected, so everything should work now. Perfect. let's do some regular Python stuff and then we're gonna time it. So some functions we're gonna use, and you should be familiar with this. If not, not a big deal. We're gonna use lots of these as we build our ML architectures. But the rectify linear function, one of these activation functions, essential, especially for neural networks, is the most simple one. So all we're gonna return here is whatever is the maximum of 0 or whatever value we're passing on. Extremely simple, extremely powerful. That's a rectify linear function. Let's also do softmax, another activation function, especially used in binary classifications. And we're gonna return jmp.exponent. The formulas for these are everywhere. I'll do a sum of jmp.exponent of x, and the axis is 0. Regular formula for softmax. We will check lots of actual papers with formulas later. For now, we're just gonna do some simple stuff. And let's also do cross entropy. It's a really good one. We're gonna pass in x, y, and in here we're gonna return. We're always trying to minimize this, so that will be jmp, that's sum. And if you're familiar with these formulas, you should already know that this will be y times jmp, that logarithm of x. There we go. Those are our really common formulas in machine learning, activation functions, and a cross entropy. Especially that will be a loss function or a cost function. So let's define the next value. This will be, you can do a range in JAX by calling it a range, the same way you will do it in NumPy, for example. And you specify a range as a float. So this will go from 0 to 6. Now, in order to do some debugging, let's test our functions. That will be value of x. We're also going to print softmax of x. And we're also going to print the cross entropy of the softmax of x and comparing that to x. And there we go. As you can see, the first one, obviously the values in here are going to be the same because that's what ReLU, rectifier linear, is doing. You can see the softmax values in here. If you don't know, it's a way of normalizing your functions. And the cross entropy is the scalar value we want at the end as we diminish our loss function. So that's 26. Regular stuff, nothing you can do with regular Python or NumPy. So let's start checking some benefits of using JAX actually. So let's import some libraries. So from JAX, let's import random. And let's do some random ranges. So we need a key for this. The key is going to be random, that library from JAX. And we can use a PRNG key. For this, you can read about this in the documentation, by the way. I'll go a bit faster. And we can also do a soft key for this. This is just how are we randomizing these numbers so we can use, we want big random numbers. So let's just print the soft key, for example. Right? As we're doing our computer science refresher, we know we're going to be handling lots of big numbers, very chunky numbers in our models. So that's why we're doing kind of this simulation of data, very synthetic data at this point. Now, if we define next, we can do a normal distribution, for example. So let's do a random.normal. And in here we can pass in the key, which we just built. And the parameters for this sometimes are a little bit strange, especially with the syntax for JAX. But we're going to specify 1 million like this. And you can add a second parameter when we're going to leave it empty. But that will be a random distribution, and that's the value of x. And then we can time it. This is just doing a regular JAX operation. So we're going to time one of these functions. So we're going to pass x. That big normal distribution we're doing in x, we're going to pass it to the ReLU function. And we're going to time it. So Remember, all of this is running on my CPU currently, so let's wait for the result. There we go, 169 microseconds. And you can see how many microseconds per loop. Remember, we're doing a loop here. And you can see it's doing 7 runs, 7,000 loops each. So great numbers, just by using JAX as it is. But we can improve that. Let's use JIT, which is one of the great attributes and functions from JAX. I always remember JIT as just import one time, but that's not what it stands for. If you see the documentation, it stands for just in time, which is extremely powerful, especially with GPUs or TPUs. We're not using tensor processing units at this point. So let's test it with this. We are just gonna import JIT. Now, we're gonna have a JITed version of our ReLU function. We're just gonna call in JIT on ReLU, which is our function we defined. And in here, let's do a variable. That's gonna be our JITed ReLU, and I'm gonna pass in X. X is that big chunky range we did, that normal distribution we did. So if we time, for example, again, the same thing, this time is gonna be ReLU of A. Let's check the difference. Now, this might not look too much to you, but in a production with billions or trillions of data entries and extremely big numbers, these differences are night and day. Just going from 169 microseconds to 167 is a lot, and per loop is even more efficient just by using JIT. So these are some really cool tricks with JAX. And again, I would definitely advise you to explore this a bit further and try to apply that in your regular day-to-day mathematical functions. I'm gonna just paste some from the documentation and I'm gonna come back and let's keep exploring this. Okay, let's keep exploring this. I have this ReLU function definition. It's doing some calculations. We're doing some random normalizations as well. And we're gonna time that function. So if I execute this, let's check how long it takes. Okay, this time 1.34 milliseconds, before it was microseconds. And then let's use the JIT version for this. See how fast it is if you compare this? Now we went from 1.34 milliseconds to 375 microseconds, which is insane. That's how better this is. And last but not least, one of our more fundamental operations in AI, matrix multiplication. You can see I'm using the JIT decorator in one of the functions. They're doing the same. And if you time the regular one, regular but still JAX, it's really fast. But if we time the one with the JIT decorator, this sometimes is misleading. You can see it's actually a little bit slower, but per loop, you can see how fast it is. So there are many different versions about performance. There are many different versions about checking these kind of operations, but mainly just wanted to introduce you to JAX. Really powerful, and it's gonna be an extremely important tool in your career. Okay, now that we have a quick introduction to JAX, we're gonna check NumPy now. So let me create a folder, call it NumPy, and inside let's have a very initial set. So we're gonna do some indexing and we're gonna check some concepts about NumPy and overall just basic containers. But I'm gonna call this one MP practice.py. And actually, let's make it a notebook. I just need to select a kernel again. Pretty much all my kernels have NumPy, but let's do scikit-learn. And there we go. As usual, we're gonna start by importing NumPy as NP. Great, and from here we do a bunch of operations. So let's just create a variable called this A, and as usual we can just do a range. For example, if we do a range and establish the start and stopping points like this one. So if we check A, is nothing more than that. It's just a basic container and a range. But already, and the main difference between this and regular Python everything in NumPy by itself, it's a library built in C, the C language. That's why it's so much faster than regular Python. Compiling wise, there's a bunch of things happening in the backend, but instead of hard coding some data type like a long integer by default in Python, you can actually establish different data types in NumPy. So indeed, all of these, you can actually make them, for example, uint 8-bit integers, or 16, different precision values for this. And that will allow us to do the calculations we need to do for AI. So it's extremely important to understand that difference. Rather than using vanilla legacy Python lists and containers, NumPy will outperform all of that, because again, we are seeing Python right now. This is an IPython notebook, but we are actually executing a C program in the backend. And most modern technologies, most modern libraries, they work the same way. PyTorch, TensorFlow, JAX, a bunch of modern libraries will do exactly the same. They are C libraries, but obviously Python is more popular and way easier to type and pretty much do an entire production just with Python. But the reason why it's faster, and they keep getting faster and faster, is because of all of these compilation tricks. So you are executing C libraries. Now let's keep going with this. We can see we're just creating a basic container. Obviously we can index and section this and slice this. For example, give me from 2 to 6. That will be those values. Very simple, just slicing. The same way you will do a regular Python list or a Python array. But let's start checking more operations. Let's do something called broadcasting, which is basically setting a chunk of data to a different data, for example. So let's do some initial slicing. So from 1 to 5, for example, we can actually broadcast this to new values. So if we do equals to another number 50, for example, if we check A again, we have transformed those values, aka broadcast these values into the new values we are setting it in here. Now, some things to keep in mind is if we create another variable, let's say this one is going to be equals to some section of this, let's say from the beginning to number 4, we are setting a new variable. But this is a reference copy, it's not a hard copy. So let's check B now. Right? We have this section representing the data for B. So if we do some operation like this, let's take everything in B and let's say that equals to another number. So let's check B again. Now we have this. But if we check A, you can see all the changes are actually in A as well. So you need to be careful about this. The reason this is happening is actually to avoid memory problems. We are passing in by reference. If you know about C or C++, when you pass in by copy, by reference, by default, these kind of operations will do by reference to save memory, to be more efficient. So if you need to do some kind of copy, you can just do it with the copy command. So like this. And obviously you will assign this to a new variable. Okay, let's start just checking some very basic matrices. So let's call this one AM, just to check some simple. Let's manually create a 2-dimensional matrix. Let's have some values in here. Okay, a 2D matrix, very simple. But remember, if you do it like this, this is a regular Python list. It will be a regular Python array. So we can do np.array and encapsulate all of this in this function. Now this is going to be a NumPy container. It's going to be a two-dimensional matrix, but it's a NumPy container. And if we show the matrix, it will be the same types we were checking before. So that's how you create a NumPy array. One of the abilities you need to have from early on is two-dimensional slicing. Meaning we need to graph, for example, some section of this matrix. And the usual way of doing this is, for example, let's say we need to graph this upright corner of this matrix, 4, 1, 4, 5, these values in here. How can we do that slicing when we have two dimensions? First of all, we know we need to iterate in the array. So for example, let's start checking this. If we do from 1, because the first column will be 0, all the column that's 3, 1, 6. So we want from this one up to the end. But remember, we are iterating in the rows first. So we do want the 0 row, which will be 3, 4, 1, 1, 4, 6. So always remember that order. We are starting on rows. So that will be from 0. The last number is not going to be inclusive. So you cannot say from 0 to 1. Actually, let's try that so you can see. You see it's just doing the first row because you need to add one basically, because it's not going to be inclusive. Now we have those. That will be the first rule. If in here we set a comma, that will be for the next operation, which will be the columns. So now we want to go from 1 all the way to the end. If we do that, we have successfully graphed the corner we were trying to do. If we have more values in here in the columns, it will go all the way through the end because we didn't specify anything in here. If you want to be precise, just add a number in there so you can capture whatever you want. This is really important because once we start dealing with features in, or the kind of 2D matrices we're going to be dealing with, like images and whatnot, sometimes it's really important to know this. Obviously, manually slicing thousands of pixels, no one will do that. But still important because remember, we might be dealing with CSV datasets and we need to do some kind of slicing for some specific features, or we need to programmatically train the model to capture this kind of data. So knowing the shapes, knowing all the important order in rows and columns will be really, really essential. Let's check other operations. Sometimes it's really useful to create like empty matrices, empty containers. So for example, let's overwrite B. We can do np.zeros. This will create a container full of zeros, and inside you can specify the shape. For example, give me a 10 by 10 matrix. That's gonna be full with zeros. Because sometimes imagine this as our bits, right? True or false. Sometimes you're gonna keep track on graphs or other kind of matrices you're doing operations. Maybe you need to toggle this one on and off some of these values. And essentially that's how machines learn at the end of the day. So it's important to know shapes. This is really, really important. We are passing that shape in here, 10 by 10. That will be 10 rows by 10 columns. Or you can do the opposite, np.ones, which will create a matrix full of ones. All right, let's keep checking some concepts about NumPy and why it's really important. If you dig around more in the concept of broadcasting, it will be how you do calculations with different shapes in the arrays. You should definitely be familiar with the concepts about matrix multiplication, about the shapes and mismatch of shapes, because that's the number one problem and issue overall in machine learning, mismatched shapes, all the way you treat your tensors and everything. So broadcasting will be that main concept of how NumPy is going to treat the arrays of different shapes during these mathematical operations. Sometimes there's going to be some tricks like vectorizing, padding, adding a bunch of stuff, and the regular way, which is obviously transposing a matrix. Again, concept you should be familiar with. If you do this really quickly, if you have some sort of matrix with some values, for example, this will be 1, 2, 4, 6, 5, 2. This will be a 2 by 3 matrix, right? If we have a multiplication with another matrix, if they are the same in terms of shape, so that will be another, for example, the numbers here, they are the same shape. So the result will be the same shape as well. And this is very easy because you're gonna do element-wise, so you're gonna multiply each term of the matrices. Obviously, that's not the case most of the times in what we're doing here. So in some cases, we need to transpose matrices. We need to do some kind of treatment to matrices. So I would recommend you to dig around broadcasting a bit more. But the number one rule, we do have some rules for matrix multiplication. So let's ignore this one for a second and let's create a new one. So say we have a matrix like this. We have some numbers, right? Let's analyze the shapes. We can't work with this matrix because the way matrix multiplication will work will be, if we start with the first term, for example, 1, we're going to multiply this row by this column. And obviously, immediately we'll see the issue. If we have 3 elements here, 1, 2, and 4, that's of length 3, we cannot use this rule because we cannot multiply all the elements because we are missing elements in here. So this is not a compatible shape and we cannot do that operation. If we analyze, so if we expand this matrix to have more numbers, for example, like this, now you can see this operation will be valid. And an easy trick to remember of this is checking the shapes. Again, shapes, one of the most important concepts we do here. The shape of matrix M is 2 by 3, and the shape of matrix C is 3 by 4. As long as these inner numbers are the same, we can do the operation. We can do a matrix multiplication. It could be the case that the matrix is in a reverse order. So for example, let's say the matrix is going to be 4 by 3, right? So let's say we have some numbers again. So if we have a matrix like this, we run into the same issue because if we check this of length 3, we are off by 1. This can be a 5. These are horrible numbers, but you get the point. We are off by 1 here because we cannot use all these elements. So the way we can do about this, if you check the shape, we can rotate this matrix, meaning we're going to swap the rows by the columns. And that operation is called transposing a matrix. As a standard on any libraries, it will be a capital T. So if we transpose this matrix, we're going to rotate that, and now the shapes will be compatible with this, because if you check the rotation for this, we're coming from a 4 by 3. By swapping those, it will be the same as up here, and now we can do this operation. So transposing matrices is something really, really essential. As we do experiments, you will check about grid meshes, about stacking, about raveling, unraveling, which is basically flattening some of these in from maybe 2 dimensions to 1 dimension and stuff like that. Lots of different operations you need to be familiar with, because you're going to use all of those. And on a daily basis, I can guarantee you will be doing a lot of those operations. Now, really quickly here, I'll draw like a roadmap of something we do very commonly. So we have our data. We are ingesting our data into our model. We do some explorations. We test with different models. We do training either in CPU, GPU, all the architecture, everything. When you're doing this, like the first step, maybe exploratory data, or you're exploring your model, the results, you're gonna do a lot of plotting, right? You need to visualize that, maybe some bar plots, maybe some scatter plots, and a bunch of different ways of visualizing your data. All of these will only work on CPU, right? So most frameworks will have the 2NumPy method, for example, which will convert these results into NumPy containers, and we can perform all the arithmetic operations or whatever we need to do with those NumPy operations. Another reason as well is because the result of your model by itself is going to be one thing, but using it is going to be another thing. So in your production, I can guarantee you at some point to actually use your application, your model, whatever it is you're doing, you need to do some transformations as well. You need to adapt to the data you're using at your company. Most of those operations can be in the CPU as well, and it will be in some sort of NumPy operation. That's why it's important to understand this. And again, at the core of every library, it will definitely be lots of NumPy operations. Maybe they will be in the very back end, maybe they will be very explicit, but they are being used. So everything is happening here. So this is a high level concept. And as we go, we're gonna check if we need to transpose a matrix, if we need to do some broadcasting, if we need to do some padding, so alterate some matrices, what kind of mathematical operations we need to do, especially when we're dealing with neural networks, exponentials, a bunch of things that we're gonna use, and NumPy is gonna be our main library. So from time to time, check the documentations, try to do some operations yourself, but we're gonna check it as we build our architectures regardless. Okay, let's check some more NumPy concepts based on the previous video. So we're just gonna do some NumPy 02 or something. It's gonna be an IPython notebook as well, making sure we are in the correct kernel. This one has NumPy, so we're good to go. Now, if we import NumPy as usual, we can start doing some operations. So as before, let's just do some kind of two-dimensional matrix. Let's do some random numbers in here, and it's easy to work with 2 dimensions. Our tensors will become insanely complex, and we will have like n number of dimensions. We can obviously see A, but we need to make it a NumPy container. So far it's a regular list. So let's call this one B, and it's gonna be equal to NumPy.array from A. So if we check B, now we have a NumPy container based on A. So we have a 2D matrix. Let's use some NumPy functionality. So if we do, again, capital T, it will be transpose. So if we check that, now we can see we swapped the columns by the rows. So 1, 4, 5 was the first column, now is the first row, and so on. Usual operations you can do from time to time. Now, that will be our B. We still have obviously the original B, and then let's do another container. So let's call this C. It's gonna be again a 2D matrix. This time let's do it NumPy.array, so we don't have to cast it, but is another container. Remember the rules. For now, we're just gonna keep it as with the same dimensions, so we can actually be more organized. So it's gonna look similar like that, and then we have obviously we need to pass this as one argument. So what we can do is we need to make it a matrix. So I was not adding the second dimension, it was just 3 arguments. Now obviously this is working, just be aware of that kind of things, but we have A and B. We can perform multiplication, so that will be a dot product. So let's call this one E. It's gonna be the result of B dot C. And if we check E now, it's gonna be that result of that matrix multiplication. Also, you can do direct operations. If you do the add symbol, for example, it will be a matrix multiplication as well. Now, as you do these operations, later we will talk about some concepts like lazy evaluation, if you're not familiar, that will become key as well. And some frameworks will have this and some other ones won't have lazy evaluation, which it's all about order of instructions and handling performance as well. But for now, this is just some basic operations we can do with this. Now, we can also do, for example, if we take that result, which for now is E, where we have the dot product, we can do MP, we can do another variable actually. We can use the where command. We're gonna pass in here some values. Let's do where E, for example, is whatever variable, but we're gonna construct it this way, where these values is less than 20. And we can also do, for example, 10 to the power of E. If we check F now, that's gonna give us this result. Where you can see this, we are kind of masking these values. So we're saying we're gonna perform an operation. So we're gonna do 10 multiplied by every value we're gonna pass on. This is gonna iterate through the matrix. And as you can see here, it's not touching any value that is less than 20. So if you keep an eye on here, every other value got multiplied by 10, except the ones that are lower than 20, which is just the first one. I cannot stress enough how important this is. and it's one of the main functions I use all the time with NumPy especially. This kind of masking, filtering, sometimes we're going to apply that directly into our tensors, so it's really, really important. There are lots of other functionality. I'm not going to type everything, but for example, the any operation. So if you have, let's say, an array of all booleans, you can use some functions like any to identify if every single value inside that container or matrix or whatever is indeed boolean. So it will return true or false, and operations like that. Really useful when you're doing some predictions as well. And by the time we're using predictions, we're using our models, all of these will become really, really handy. So just to extend some of these concepts, all of these will be in the documentation. And once we start building our functions to plot, our functions to use the model, to do some extra calculations, to actually use what we are training for, you're gonna check about ravel, unravel, stack, mesh grid, and all of that. It will come with practice as well. Okay, so before we even start doing all of data exploration, models, ideas, working straight in DCCs and all of that, let's take a quick reminder about this kind of pipelines and normal standardized strategies for development. As usual, if you have a picture like this, there will be some changes depending on what you do, but the idea is always the same. First of all, before even going into this roadmap or this workflow about AI development, as we were talking before with the solid principles and design patterns, there's also the concept about DevOps, CI/CD, and the life cycle of whatever it is you're doing as a product. So, as a common standard, and this is regardless of the industry, for example, if you have some starting point, this will be our starting point of our product or development we're doing. But in this phase, usually production and high-end supervisors will talk about the ideas, the overall work of concept, what is expected to do, scope of work, and all of that. So this is mainly more in the project management side of things. So lots of concepts in here, and from here it will go more into detail and technical parts of the production. So it will go into the next stage, where you define if you have everything crew-wise, if you have all the tech required for this product, and so on. And from here, you start developing. So you assign that to different departments, different crew members. And then if you work in an agile methodology, you will have some common standards as well. And then as you do your reviews and everything, you have some sort of output. This can be for internal reviews, stakeholders in the company, and so on. But at some point, it will go also to, for example, the client. Obviously, if the first stage is planning and everything, this is a loop, right? Because at the beginning, it's not going to be the final product. Lots of things happening, you do have some feedback, some notes, and based on that, you go back to the first stage, right? And then you need to address those changes and do all of that, and then you're back in the loop again. Distributing tasks or doing this, and this will be like multiple iterations until you have your final output. This is a regular production environment. Can be a game level, game development, can be a VFX shot, you name it, like anything, regardless of the industry, kind of like follows this pattern. In the terms of CI/CD, if you're not that familiar, it will be mainly in tech, in software, and it's all about automation, because lots of these steps, it will be extremely useless if it's done by a human. So you need to automate this as much as possible. And yes, there are a lot of machine learning involved in here nowadays to automate a lot of these processes. So for example, auto-publishing things, auto-deploying, auto-building your programs, auto-QCing your programs, and all of that. Even predicting if the client is already going to like it or not. Things like that. And if you think about that in a software or a feature in an application, it's going to be the same, right? For example, like Instagram or Facebook, it's not like it's the first version and then they stop working on that. You have your first version, then you have lots of feedback, you are adding features, removing features, and it's a life cycle. If you take that in mind, all of this, and all that production concept, all of that will apply in smaller sections as well. So in terms of a machine learning model, you also have the first stage of the machine learning model, which is defining the use and maybe the problem you're trying to solve. So you're doing the definition in this step. What are you trying to do? What are you trying to develop? Is it a chatbot? Is AI-based automated animation? Is for maybe your VFX house AI auto QC of your assets, and a bunch of things like that. you're defining this. The next step will go in what kind of data you have in order to build your model. So all of these will be a data pipeline, for example, or part of the data pipeline. And we will talk in depth about this a bit later. From here, you will start doing like small experiments and maybe trying to build the first architecture of the model and do some iterations, checking different metrics, checking different models, and do a bunch of exploration in here. You will have your metrics and then you're gonna deploy your model as well. Obviously this is gonna be internal, but obviously you need to build and deploy. I'm just skipping or merging a bunch of steps into one, but then you have a deployment phase in here. This will be in a cloud server most of the time. You're deploying your model and then you need to run some tests. And you need to do some configurations, like if the end goal, for example, is a mobile app, is not going to be the same as a user using something from the cloud in a powerful server, right? You can't just do like a massive heavy model and expect that to work in an iPhone, for example. So different things, the stages of configuration, but you do have all of this. And then as you keep going into this, you're going to monitor everything. Is the model behaving correctly? Is doing correct predictions and all of that? And at the end, you also have your feedback or response, either from users, tester groups, or your client. And then you go back with those notes to the beginning to replan again what's happening. And then you go back into the loop again. So if you keep this in mind, this is just for one, for example, machine learning model that maybe is just one tiny part in the whole pipeline up here. So that's why you go in different sections, but the logic is always the same. So keeping this in mind, we also want to take the same route and try to do this as we go, trying to keep it production ready and with production concepts. Now, one part of this, if we go back to our picture, will be to kind of like understand the process about this. So if I take a look here, for example, at the beginning, maybe the CEO has an idea, right, about some kind of model we need to do. It doesn't have to be the CEO, obviously, whatever you want to do. And at the same time will be, for example, what's the end usage for this? So let's say we're doing an AI-based game or AI-based texturing for your VFX shot, whatever we want to do, whether we're trying to automate and apply this, experiment or not. We have both sides. The users using this product and whatever came up with the idea, for example. They will always go into this middle stage and the product management will establish the business requirements for this. So for example, and it says right here, the product manager will translate business requirements into technical requirements. Really important. All of these in this stage will go to the technical lead. By the way, this is my position. This is what I do. My job title is technical lead. So I'm here in this whole pipeline, in case you're wondering. But what we usually do is, based on those technical requirements, we actually distribute the tasks for the teams. And we want to manage this as well. Lots of times in different industries, in different studios, I will say, or companies, you also go hands-on, and I do go a lot hands-on and build a bunch of things myself, but mainly it's about structuring the whole project technical-wise. So we will assign tasks, for example, to the machine learning engineer, to the data engineer, and MLOps engineer. By the way, what we were doing here, this is considered MLOps. And there's a bunch of other steps as well, it's not just this. But back here, you can see what we're trying to do with each department or specialty. For example, the MLOps engineer will provide automation and monitoring. That's when I was talking about this CI/CD concept. In regular software engineering, you have the DevOps pipeline. If you're introducing machine learning, it will be the MLOps pipeline. So it's all about automation and trying to do something more programmatically, because you're using a lot of data, lots of models. You need to be more efficient in the way of doing this. And monitoring is key. Monitor about everything, not just how your model is performing, monitoring about the data itself. Is it clean? Is it reliable? All of that. The data engineer will create data pipelines, and the MLOps engineers, they also create data pipelines. We're gonna dig around this a little bit more in the next videos, but there is a data pipeline, and there are many different aspects of a data pipeline. From here, there's a lot of different things. And you can see by the time you're talking about data, we do have to ingest data in our company, right? In our production. So, and then you have all of these aspects down here as well, all of these steps. So the data architect maybe has to structure the data for one side of the company, maybe has to transform, derive. There's so many things. Data by itself is a whole universe and careers, but we are merging that in our production. And as you can see as well, the machine learning engineer will be the ones to graph all this data from all of these departments, from all the production, and architect the models. So every time we're doing exploratory data analysis, we're actually grabbing data that was prepared from other departments from the company, and then we are creating the models in this iterative approach of which model is the best, metrics, and all of that. Once we have that, we are generating data as well, because everything is still flowing into the same pipeline. So as we do that, we graph this data, and you can see this circle in here because maybe we need more data, we need to change the data, and this is also like a big loop on here as well. But data by itself is not just for machine learning. All companies are using data. So maybe in one stream of the flow, you need to do something different for your company. So many different reasons, many different things, but you can see data scientists, they will actually analyze that data. And then potentially they can grab that data that they did some transformation and feed it back to the machine learning engineers. You have all of these different components, and at the end, you will always come back because the end user will need to test all of this. And then you expose this to user. You have the full stack development, front end, back end, all of that. And then obviously from here, you will have always some feedback or new feature and all of that. And then you come back by department and check all of this production again. We're going to check about data in the next videos, and then we're going to jump and do some really quickly reminder about using pandas and other kind of database workflows, and then we're going to jump straight into doing the models, extracting data, and then doing our fun stuff.